Hey guys, I'm Bhavya. I'm an instructor at Skiller Academy. In this video, I will discuss the problems of code drift. So this contest was on maths this time, and I'll discuss the first two problems in this video, which will be the very easy problem and the medium problem. So let's look at the very easy problem first. A shopkeeper sells daily A units of item and his shop remains closed on weekends, that is Saturday and Sunday. We need to find the number of weeks it will take to sell B units of them. Assume that the first day will be Monday and then return the seal value of the number of weeks. For example, if it takes 9 days to sell all units, then return 2 weeks. So for example, if
A is 3 and B is 7.
that is each day we sell 3 items and we need to sell 17 items in total. So on the first 5 days, shopkeeper can sell 15 items. After that, we will have a weekend, which will be Saturday and Sunday. So on 8th day, we will sell the remaining 2 items. So the number of weeks required is actually 2. So let's look at the solution outline. So actually first, let's find the number of days it will take to sell all the items. So since we are selling A items each day, so we'll keep selling A items each day. And we will do that until this value actually becomes greater than or equal to B. So for example, if the total number of items are 17 and we sell 3 items each day, we will sell 3 items the first day, then 3 items the next day, 3, so on up till the items become 15. And now we will only sell 2 items. So we can say that the total number of days required will actually be seal of B by A, where seal is the smallest integer greater than or equal to B by A. So for example, for 17 by 3, this will be 6. Because this is the smallest integer which is greater than or equal to 17 by 3, because the value of 17 by 3 is something around 5.6666 and so on. So now we know the number of days. To find the number of weeks, we can actually use a similar idea, because we know that in a week we will only open the shop for 5 days. So the total number of days will be seal of days by 5. And to calculate the seal of P and Q, so if we need to calculate the seal of P by Q, we can actually use the formula P plus Q minus 1 by Q, where this is the integer division. So for example, for 17 by 3, this will be 17 plus 2 by 3, which is 19 by 3. And this will be 6 because we are only calculating the integer division. So let's actually implement this. So we assign days as B plus A minus 1 by A, which is seal of B by A. So days is seal of B by A. And we will simply return days plus 4 by 5, which is seal of days by 5, which is our answer. So let's actually submit it to check. So we have written the code here and it works on the sample cases, and let's submit it. It works on all the cases. Now let's look at the second problem, which was the medium problem, count good subsequences. So an array is good if all the elements present in it have the same frequency. For example, 2, 3, 3, 2 is good because both 2 and 3 have frequency 2. 2, 3, 2 is not good because the frequencies of 2 and 3 are 2 and 1 respectively. You are given an array A, you need to count the number of non-empty subsequences which are good. So since the answer can be large, you need to return it modulo 10 raised to 9 plus 7. And the length of A will be around 2 into 10 to the power 5, and the length of AI will be between 1 and 10 to the power 9. So we need to find it modulo 10 raised to 9 plus 7. So for example, if A is 1 to 1, the total number of good subsequences will be 6, because all subsequences of length 1 are good because the frequency will be 1. Similarly, all subsequences of length 2 will be good because for the array subsequence 1, 2, the frequency is 1. For the subsequence 2, 1, the frequency is 1. And for the subsequence 1, 1, the frequency of all elements is 2. But the array of length 3 will not be good because the frequency of 1 is 2 and the frequency of 2 is 1, which is not equal. So the total number of subsequences which are good are 6. So let's look at the model solution. So let's actually take a bigger array 2, 5, 3, 2, 3, 5, 7. Let's actually add another 2. So since we need to find subsequences, we can actually ignore the order of elements because the subsequence is equivalent to choosing some elements out of the given elements, and the order here does not matter. So we can actually sort this array. So this will be 2, 2, 2, 3, 3, 5, 5, 7. So what we'll do is, instead of iterating all the subsequences, we'll fix the frequency f. F is the frequency of all the elements present in the subsequence. So for example, if the subsequence is 2, 2, 3, 3, and we know that this is good because the frequency of 2 is 2 and the frequency of 3 is 2. So f will be 2 for this case because all the elements have frequency 2. So we are actually fixing the frequency f of all the elements present in the subsequence. So let's say f is 2. If f is 2, how many subsequences will be there such that all the elements have frequency 2? So consider the element 2. There are 3C2 ways to select 2 elements whose value is 2. But we can also ignore the element 2. So there is one way to actually ignore them. And if we want to take it, there are 3C2 ways. Similarly, consider 3. There is one way to ignore it, that is to discard the elements 3. And if we want to take it, we will have 2C2 ways, because we have two elements whose frequency is 3 and we want to take two of them. So there will be 2C2 ways. Similarly, for 5, the number of ways will be 2C2. And for 7, the number of ways will be 1 plus 1C2, and 1C2 is actually 0. So this will be 1. That actually means that we can only ignore the element 7. We cannot take it because the frequency is 1, and we cannot select two elements because we only have one element. But notice that we need to subtract 1 here as well, because we have to subtract the case where we ignore all the elements. That is, we get an empty subsequence and we only need to count non-empty subsequences. So I'll subtract 1 here. Now let's actually do it for any general f. So if our frequency is, so from here you can notice that we only care about the frequencies of elements, not the values of elements. So let's store the frequencies of elements f1, f2, f3 and so on up till fk in sorted order. So for example, here the frequencies are 3, 2, which is the frequency of 3, 2, which is the frequency of 5, and 1, which is the frequency of 7. So we'll store this list in sorted order 1, 2, 2, 3, and the sum of these frequencies will be equal to the length of this array. So because 2 plus 2, which is 4, 5 and 8, and the total number of elements are 8 here as well, because the sum of frequencies of elements will be equal to the total number of elements. So we are storing this list in sorted order f1, f2, f3 and so on up till fk. So let's actually fix f. All the elements will have frequency f, and we know that the number of such subsequences will be 1 plus f1 cf into 1 plus f2 cf. That means that we can either ignore this element, and there is only one way to ignore it, or we can select f elements, which will be f2 cf, and so on up till 1 plus fk cf, and we will subtract 1 here as well. So this gives the total number of subsequences for any f, and we will do that for all f from 1 to fk, because after that we cannot have f as fk plus 1 because the maximum frequency is fk. And we will simply add this value. For all f, and this will give us the total number of subsequences. Now let's actually think how fast this actually is. So if we were to know a way to calculate NCR in O of 1, so let's say we know that we can calculate NCR in O of 1 using some pre-processing. I'll describe it later, but let's say we know that. So we can actually calculate NCR in O of 1 with some pre-processing. Now how fast calculating this formula will be. So notice that if our frequency was 2, 3, 5, 7, 8 or something like that. Let's say our frequency here is 2, 3, 5, 7, 8. And we are considering f equal to 4. So if we are considering f equal to 4, we only need to consider the elements 5, 7 and 8, because for 2 and 3, this value will be 1 plus 2c4 into 1 plus 3c4. And we know that NCR where n is less than r will be 0. So this will only contribute 1 to our product. So we can actually ignore these two elements. And since we have sorted this frequency array, we can find the first element which is greater than or equal to 4 using binary search. So we can use binary search to find the first element which is greater than or equal to 4, which will be 5 in this case. So now let's actually find what will be the contribution of each element. How many times will each element be considered in our formula? So if we have a sorted array of frequencies f1, f2, f3 and so on up till fk, fi will only be considered for all the f from 1 to fi, because after that this term will only contribute 1, because we know that 1 plus the contribution of this fi will be 1 plus fi cf for all the f, and if f is greater than fi, this value will be 0. So this will only contribute 1, and we will ignore that, as we said here that for f equal to 4 we will ignore 2 and 3. So this fi will only be considered fi times. So our total time complexity will be sigma fi, which is n, because we know that the sum of frequency is n. So to make it more clear, considering this example 2, 3, 5, 7, 8, for f equal to 1, we'll consider this element, this element, this element, this element, this element. So all the elements will be considered for f equal to 1. For f equal to 2, again we'll consider this element. So this will be considered twice now, this will be considered twice, this will be considered twice, this will be considered twice, this will be considered twice. For f equal to 3, we will actually not consider 2 because this is lesser. So the next element which is greater than or equal to 3 is 3. So I'll only consider the elements from 3 to 3, 5, 7 and 8, and so this will be considered thrice, this will be considered thrice, this will be considered thrice, and this will be considered thrice. For f equal to 4, we'll only consider 5, 7 and 8. So all of these elements will now be considered 4 times. For f equal to 5, we'll consider 5, 7 and 8 again. So this will be considered, all of these elements will be considered 5 times now. For f equal to 6, we'll consider only the elements 7 and 8. So they will be considered 6 times both. For f equal to 7, again both the elements will be considered. So both these elements will have been considered 7 times now. For f equal to 8, we'll only consider this 8 and so this will be considered 8 times now. So you can see that each element is considered equal to the value. So fi will be considered fi times, so the total time complexity is O of n here. But now, how to calculate NCR in O of 1 with some pre-processing? So we know that NCR is equal to n factorial upon r factorial upon n minus r factorial. So what we'll do is actually store all the factorials from 1 to n, and we know that factorial of I is equal to I into factor of I minus 1. And this can be done using a single loop, and we'll actually obviously do this calculation modulo mod, which is 10 to the 9 plus 7 in our case. And to calculate inverse of factorials, so we know that if we know fact of n, to calculate inverse factorial of n, what we'll do is we'll calculate factorial raised to mod minus 2 modulo mod using Fermat's theorem, because we know that the inverse of a modulo prime number p will be a raised to p minus 2 modulo mod, and a raised to p minus 2 can be calculated using binary exponentiation. So this will be inverse factorial of n. So we can calculate inverse factorial of n using this way. So this will be O of n, and this will be n log mod, because we are doing binary exponentiation, and we know that binary exponentiation will take log of power time, which is log of mod here. But this can actually be done fast. So if we can calculate inverse factorial of n using binary exponentiation, what we can do is to calculate inverse factorial of n minus 1, we can multiply inverse factorial of n with n and then take the modulo. So this will give us inverse factorial of n minus 1. This is because inverse factorial of n is 1 upon n factorial, and we multiply it by n, and this will give us 1 upon n minus 1 factorial, which is equal to the inverse factorial of n minus 1. So we'll actually look at the code to make it more clear, to make all the ideas combine all the ideas and make it more clear. So here our solution starts. We'll pre-process, that is, we will calculate the factorials and inverse factorials. So our pre-process, we store an array f, which is the factorials, and an inverse, which is inverse factorial. So f of 0 is 1, because we know f factorial of 0 is 1. And now we'll iterate from 1 to n and assign f of I as I into f of I minus 1, because that's the definition of factorials. And now we assign inverse factorial of n minus 1 as factorial of n minus 1 raised to m minus 2, and that can be done using binary exponentiation. Now for calculating inverse factorial of I, what we'll do is we will use inverse factorial of I plus 1. So inverse factorial of I will be I plus 1 into inverse factorial of I plus 1, because inverse factorial of I plus 1 is 1 upon I plus 1 factorial, and we'll multiply I plus 1 into it, and that will give us 1 upon I factorial. So in this way we can calculate factorials and inverse factorials, and the time complexity of preprocess function will be O of n for calculating all the factorials, and then we calculate inverse factorial of n minus 1, and that is log of mod, because we use binary exponentiation here. But now we again use a single loop, so we'll again have an O of n. So we can actually say that this is of the order n, because log of mod will actually be quite smaller. So we can actually do this preprocessing in O of n. And now calculating NCR is actually quite easy. If r is greater than n, we can simply return 0. Otherwise, we know that NCR is n factorial upon r factorial upon n minus r factorial. So we'll multiply factorial of n with inverse factorial of r with inverse factorial of n minus r, and that will give us NCR. So now we are actually forming the list f, which was storing all the frequencies. So we'll iterate over all the elements of array and do m of I plus plus, that is m of I actually stores the frequency of I in our array. So again we iterate over the vector and push the frequencies in our vector v. So now we'll sort our vector v, that is we'll sort the frequencies. We assign answer as 0, and we loop over the frequencies f, which I described. So f, this is actually the frequency of all the elements in my subsequence. I'll assign result as 1. Now I'll iterate over the vector only for the elements which are greater than or equal to I, because for less than I, their contribution will only be 1. So for example, if our list was 2, 3, 7, 8 and current I is 4, we'll only consider elements 7 to 8. And since our list is sorted, we'll use lower bound, and lower bound actually returns the smallest value which is greater than or equal to I. So for example, if I is 4, the smallest value which is greater than or equal to 4 is 7. So it returns a pointer to this element. And so we'll start from here and move till the end of the array. And now the contribution of any element will be 1 plus star it is the value at this pointer, which is fi c f. And finally we will add res minus 1 to our answer and simply return answer. So as you can see that the total time complexity will be O of n. Also we have binary search here, so this will be O of n log n, and the space complexity will be O of n, because we are only calculating the factorials, inverse factorials, and a map of frequencies of all the elements. So I hope the idea was clear to you. If you like the video, please hit the like button, And for more such amazing videos, subscribe to our channel. Thank you for watching this video. Hey guys, I am Bhavya. This is the second video of code drift on maths. So in this video, I will discuss the easy problem and the hard problem. So let's look at the easy problem first. So Batman and Robin are on a mission. There is a bomb which they want to defuse, but the problem is they will have to solve a task first, which is very difficult for them. As you are their friend, they ask you to solve the problem for them. You are given a pair A, B. After each operation, pair AB gets changed to B minus 2A, 2B plus A. You are given the initial values of A and B, and you need to find and return the value of the pair after Cth operation. A, B, C are around 10 to the power 9. And you need to return the value modulo 10 to 9 plus 7. So for example, if A is 5, B is 10 and C is 2. So initially the value is 510. After doing one operation, the value will be 0.25. And then again we do an operation, 0.25 will be changed to 25.50. So final answer will be 25.50. So let's look at the module solution. So as per our operation, A, B is changed to B minus 2A and 2B plus A. So let's actually look how the values change. So initially the value is A, B. After doing an operation, the value will be B minus 2A, 2B plus A. If we do one more operation, the value of A will be B minus 2A, and B is 2B plus A here, minus 2 into A, where A is B minus 2A. So this will be 5A, and the value of B will be 2B plus A. So 2 into 2B plus A plus B minus 2A, which will be 5B. Again we do an operation, the value will be B minus 2A, which will be 5B minus 10A, and 2B plus A, which will be 10B plus 5A. Now again we do an operation, the value will change to B minus 2A, B is 10B plus 5A, minus 2 into A, where A is 5B minus 10A. So this will be 25A, and the value of B will be 2 into B plus A, where B is 10B plus 5A, plus A, and A is 5B minus 10A. So this will be 25B. So you can notice that after every two operations, the value of AB changes to 5A into 5B. So from AB we get 5A to 5B. Again when we do two operations, we get 25A, 25B, and so on. So we can say that if C is even, the value of AB will be 5 raised to C by 2 into A, 5 raised to C by 2 into B. But what if C is odd? So for example, if C is 5, then we'll actually do four operations. That is, we'll do C minus 1 operations, and we know that C minus 1 will be even. And then we will do one operation again. So for example, if we need to do 5 operations, we'll calculate the value at C minus 1, which is 4, and we know that the value at C equal to 4 will be 25A, 25B. And now we'll simply do one operation to get the final value, which will be B minus 2A, and B is 25B minus 50A, and 2B plus A, which will be 50B plus 25A. So let's look at the code to understand it more clearly. So we assign null as 5 raised to C by 2 modulo m, where m is 10 raised to 9 plus 7, and we are calculating 5 raised to C by 2 using modular exponentiation, which can be seen here. And this calculating 5 raised to C by 2 will take log of C by 2 time using binary exponentiation. Now the value of A will be A into 5 raised to C by 2, the value of B will be B into 5 raised to C by 2. We assign answer as A, B. If C is even, then we are done. We found the answer. If C is odd, we need to do one operation one more time. That is, we'll change the first value as B minus 2A, and we'll change the second value as 2B plus A, and we'll finally return answer. So the time complexity will be log of C, because we just need to calculate 5 raised to C by 2 and all other operations are constant. So let's actually look if it works. Let's submit it. So we'll test it. So it works here, and now submit it. Okay, so it works. So now I'll actually describe a solution which can do it for any P and Q. So for example, from AB, we could have done it for any PA plus QB and RA plus SB. If this was our operation for any PQRS plus SB, still this problem was solvable. This could have been done using matrix exponentiation. So let's actually look the problem, the original problem. So initially the values are AB, and let's say after doing one operation, the values will be A dash B dash. So we'll represent A dash B dash in terms of AB. So this will be minus 2, 1, because A dash will be minus 2A plus B, and B dash will be A plus 2B. So I'll write 1, 2 here, 1, 2. So this is our matrix. And let's say we do one operation on A dash B dash as well. That is, we do total 2 operations. So A dash B dash will be minus 2, 1, 1, 2, A dash B dash. But notice that this is equal to this value. So by replacing it, we'll get minus 2, 1, 1, 2 square AB. So that is the value after doing two operations. So we can say that if we do C operations, the final value will be minus 2, 1, 1, 2 raised to C into AB. So these are the coefficients as per our problem. So even if we are given some random coefficients, we could actually calculate it using matrix exponentiation and finally calculate the values of A and B. Now let's actually prove that why the values become 5A, 5B after doing two operations. So we can actually, why the values 5 raised to C by 2 into A and 5 raised to C by 2 into B when C is even. So let's actually consider that C is even. So we can write this as minus 2, 1, 1, 2 square raised to C by 2 into AB. So I'll square this matrix. So minus 2, 1, 1, 2 into minus 2, 1, 1, 2 will be, so this will be 4 plus 1, 5. And this will be minus 2 plus 2, 0. Minus 2 plus 2, 0. 1 plus 4, 5. So we can write it as 5 into I, where I is the identity matrix, 1, 0, 0, 1. So we can say that this is 5I raised to C by 2 into AB, because this square is 5I. So we can write it, and we know that I raised to any power P is equal to I. So because I is the identity matrix, so we can write it as 5 raised to C by 2 into I, and we know that I is 1, 0, 0, 1 in times AB. So the final value will be 5 raised to C by 2 into AB. So that's the proof that why the values become 5 raised to C by 2 into A and 5 raised to C by 2 into B. So you could either do it using matrix exponentiation or observe the pattern in this problem. So now let's look at the second problem, the hard problem. So India and Pakistan are playing a bilateral series of A matches. Now you know that India won exactly B matches. We know that there are ACB ways in which India could win B out of the A matches played. Here NCR is the number of ways to select R objects out of N objects. Having known that, we want to know the number of possible results in which the maximum consecutive number of matches lost by India is exactly K. We need to find that count for all K from 1 to A minus B. Since the answer can be large, calculated modulo 10 to 9 plus 7. B is less than A, less than equal to 5, E5. So for example, if A is 5 and B is 2, that is India played 5 matches and won 2 out of them. So we have 5C2 ways, 10 ways. And you can see that there is one way in which India will lose only one consecutive match maximum times, that is loss, win, loss, win, loss. And you can see that there are 10 ways, and there will be one way in which India could lose maximum one consecutive match. There are 6 ways in which India could lose maximum 2 consecutive matches, and there are 3 ways in which India could lose maximum 3 consecutive matches. So we need to return that array. So let's look at the model solution. So the prerequisite for solving this problem was inclusion and exclusion. So if you don't know about inclusion and exclusion, try to read it first and then look at the solution. So the idea was that if India wins B matches, then there will be some B plus 1 gaps. So if these are B wins, then there will be W plus 1 gaps. So let's actually call the gaps as GI. So this will be G1, G2, G3, G4, G5, and so on up till G of B plus 1. So for example, if total number of matches played were 5 and India won 2 matches. So if B is 2, there will be 3 gaps, G1, G2 or G3. So these gaps actually denote the number of consecutive matches lost by India, because we have placed all the win here, all the B wins here, and the remaining gaps will be of losses. So from here we know that there will be B plus 1 gaps. So G1 plus G2 and so on up till G B minus B plus 1. That is the total sum of gaps will be A minus B, because the total number of matches played are A and India won B out of them. So total number of losses will be A minus B, and these gaps actually denote the losses. So now our problem was, given a K, we need to find the sequences where maximum consecutive matches lost is exactly K. So what we'll do is we'll actually calculate answer of K, but answer of K is number of sequences where maximum consecutive matches lost is at most K. So for finding the sequences where the maximum consecutive matches lost is exactly K, we will calculate answer of K minus 1, because it contains all the sequences where maximum consecutive matches lost is less than equal to K, and this contains all the sequences where maximum consecutive matches lost is less than equal to K minus 1. So this difference will contain all the sequences where maximum consecutive matches lost is exactly K. So now we will calculate answer of K for all the Ks. Now given a K, the maximum consecutive matches lost is at most K. So that is equivalent to saying that Gi is less than equal to K. So we have this additional constraint that Gi is less than equal to K, and G1 plus G2 so on up till Gb plus 1 is A minus B. So this is our equation, that is the solution to this two equations will give us answer of K. Now how to do that? So let's actually ignore this constraint first. Let's ignore this constraint. How many solutions does G1 plus G2 and so on up till GB plus 1 equal to A minus B have. So this is actually a popular problem called stars and bars problem. So that is, if we have, let's say, A1 plus A2 and so on up till AN is equal to S, we are given some solutions to this equation are, the total number of possible solutions to this equation are S plus N minus 1, C N minus 1. Now, to give an intuition of why this is so what we do is, let's say we have S stars, and we take, so for example, if S is 6, we have S stars and N is 3. So what we do is, we place 2 bars, we select 2 bars, that is, we select N minus 1 bars. So we are saying that the total number of solutions to this will be the number of ways to permute the stars and bars. So the number of ways to permute this will be S, where S is 6 here, so S plus, and the total number of bars will be N minus 1, so S plus N minus 1, C, N minus 1 or S. Now why this is so? So consider any permutation. So we have star, then a bar, then again a bar, and let's say we have the remaining stars. So what it does is, the values between the bars will be the value of AI, because this bars will divide the stars into, so if we have n minus 1 bars, this will divide the stars into n parts. So for example, here we have 2, here we have 0, and here we have 3. So any permutation will give us the solution to this equation. So that was the general idea behind this. So the solution to this is S plus N minus 1, C N minus 1. So now, if we ignore this constraint where Gi is less than or equal to K, the solution to this equation will be S, where here S is A minus B, plus N minus 1, here N is B plus 1, so N minus 1 will be B, C, B. So the total solutions to this equation is ACB, which was obvious because if we ignore this constraint Gi less than or equal to K, then it is equivalent to saying that we are considering all the possible ways of India winning B matches out of A matches played. But now we have this additional constraint that Gi less than or equal to K. So what we'll do is, we'll use the idea of inclusion and exclusion. So we'll subtract the sequences where Gi gets greater than K for exactly one element. So let's say we choose any element B plus 1 C1. We have B plus 1 C1 ways to choose any element, and we will assign Gi. We want that this item selected should have the value greater than K. That is, its value should be at least K plus 1. So what we'll do is, we will write that Gi as Gi plus K plus 1. So that is equal to saying that our equation now becomes G1 sigma Gi is equal to A minus B minus K plus 1. And the solutions to this equation are A minus K plus 1, C, B. Now we will add the sequences where the number of Gi is greater than K is exactly 2. So this will be B plus 1, C 2. And now, using similar observation, this will be A minus B minus 2 into K plus 1, because we will assign this to 2 Gis. And we have B plus 1 C2 ways to select that 2 indices. So this will be A minus 2 into K plus 1 CB. And now we'll subtract sequences where we have 3 Gis greater than K. So this will be B plus 1 C3 into A minus 3 into K plus 1 CB, and so on. So we can write this as minus 1 raised to R. R is from 0 to some value. We'll find the upper bound here. And this will be B plus 1 CR into A minus R into K plus 1 CB. So this will be our formula for finding for a given K. And now what will be the upper bound? So we want that A minus R into K plus 1 should be greater than or equal to B for this to be valid, otherwise NCR will be 0. So the value of R will be less than or equal to A minus B upon K plus 1. A minus B upon K plus 1. So the upper bound is A minus B upon K plus 1. So referring the previous video, we can calculate NCR in O of 1 by pre-storing the factorials and inverse factorials. So calculating this answer for a fixed K will take A minus B upon K plus 1 time. So if we sum it for all the K's from 1 to A minus B, this will actually be A minus B log of A minus B, because we can take this A minus B out. So this will be A minus B into sigma 1 upon K plus 1, where K ranges from 1 to A minus B, and we know that the sum of this harmonic series is log of A minus B. So the total time complexity of calculating this formula is A minus B into log of A minus B. So this gives us answer of K, and for finding the sequences where the total consecutive matches, maximum consecutive matches lost is exactly K, we will simply do answer K minus 1 as told previously. So let's actually look at the code, and this will be more clear. So this part of code is actually similar to the previous problem. This all it does is actually stores the factorials and inverse factorials and give us a way to calculate NCR in O of 1. So we'll use preprocess, and preprocess was already described previously. So let's say I have assigned N as A and K as B, and previous actually stores the value of answer of K minus 1, that is M minus 1 here. So instead of K, I'm using M in the code now. So we know that the value of K will be from 1 to a minus b, which is n minus k here, and we are saying current is 0, will iterate from 0 to n minus k upon n plus 1, which is equal to saying that we are iterating from a minus b upon k plus 1. And now answer will be k plus 1 cr into n minus m plus 1 into r ck. That is b plus 1 cr into a minus r into k plus 1 cb. So we also have to consider this term minus 1 raised to r. So if r is odd, we will decrease this value, current minus equal to temp, else current plus equal to temp. And now we know that the answer is current value minus previous value, answer of k minus 1. So current minus previous plus m modulo m, and we will simply return answer. So let's actually submit it and check if it works. So let's submit, and it works for all the cases. So I hope the problem and the idea was clear to you. So the next contest will be based on binary search. And again, I think the hard problem will be interesting and for some people. So if you like the video, please hit the like button and please subscribe our channel for more such videos. Thank you for watching this video.
Hey guys, I'm Bhavya. In this video, I will discuss the problems of code drift on strings. So I'll discuss the very easy problem and the medium problem. Let's look at the very easy problem. Check palindrome. Little Pony has 3 strings A, B and C. Now he selects a non-empty substring A of a non-empty substring B of B, and a non-empty substring C of C. Consider the string S equal to A plus B plus C. Little Pony wants S to be a palindrome. Here P plus Q is the concatenation of P and Q. Help Little Pony find if we can select some A, B and C so that S is a palindrome. A, B and C, their lengths are of the order 1000. Now the first case is A equal to MA CCB, B is PCCGH and C is ABSA. Now there is a way to select a substring of A and a substring of B and a substring of C so that their concatenation is a palindrome. We can select A as ACCB, B as CC and C as A. Their concatenation will be ACCB CCA, which is a palindrome. In the second case, A is A, B is A and C is C. So since we need to select a non-empty substring, we only have one choice to select A and C, and their concatenation will be AAC, which is not a palindrome. So let's look at the solution approach. Now the first thing to think is, if A and C have a common character, let's say there is a character A here and also a character A in C as well, somewhere in this string. Let's say if this string was BABC and this string was CADE. Now we can select A and this A as a substring and any character from B and concatenate them, and we will get a palindrome. So for example, if this was DC, we could take either D or C and concatenate A, D and A, and we will get a palindrome. So basically we don't have any use for B. If A and C have a common character, then we will definitely get a palindrome. But what if they don't have a common character? Can we get a palindrome? Well, it turns out we cannot get a palindrome if A and C do not have a common character, because let's say we select some characters S1, S2 and so on, SA from A, and then some characters R1, R2 and so on up till RB from B. So these are the substrings which we choose from A. This is the substring which we chose from B. Now let's say we select some substring from C as well, T1, T2 and so on up till TC. Now for this to be a palindrome, S1 should be equal to TC. That means the first character of A and the last characters of C should match. But if they match, that means we have a common character. But we do not have a common character, so for that case, we cannot form a palindrome. So now the idea is simple, that we just need to check if A and C have a common character. So for example, here you can see that the string A is MA CCB and string C is ABSA. So we could select A from both these substrings and we'll get a palindrome, or we can also select B as well. Now the implementation is quite simple, because we can actually, let's say, keep a mask where ith bit will be 1 if ith character is present in our string. So we'll keep a mask of length 26 initially, which is 0. Now let's say if we have an A, we will set this first bit to 1, and if there is no A, then this will be 0. So finally we can just find the AND of both these masks and check if the AND is positive. If the AND is positive, that means we have a common character. There are also other ways to implement this. we could use set. So for example, we could insert all the characters of A in the set and insert all the characters of C in the set and check if their intersection is non-empty. So let me show you my implementation, which I think is easy. So we have mask A for characters in A and mask C for characters in C. We will iterate over characters in A and we will set I minus 8th bit on in mask A. That means if we have that character, then this bit will be on. Similarly, we do it for C as well. And finally, we check if their intersection is positive. That means they have at least one bit on. So the time complexity of this will be mod of A plus mod of C, since we iterate over the characters of A and C. So now let's look at the next problem. Suppose Suzuka has an empty string S. In first iteration, she adds all characters from A to Z in S. That is, S is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. In second iteration, she add all characters from A to Z 2 times each. That is, after second iteration, S will be A to Z and then A, B, B, C, C, and so on up till Z, Z. In third iteration, she will add characters from A to Z 3 times each, and so on. Now, you will be given Q queries. In each query, you will be given 2 integers L and R. You need to tell the number of vowels in the substring S ranging from L to R inclusive, assuming that S is 1 indexed. So for example, let's look at A equal to 1, 5. The first query is 1 to 5. So the string is A, B, C, D and so on up till Z and then A, B, B. So for 1 to 5, we will have A, B, C, D, E. Now the number of vowels are 2, A and E. For the substring 26 to 29, the second query is 26 to 29, we get Z, A, B. Now the number of vowels will be 2. So let's look at the solution approach. Now observe the pattern. We have first have A, B, C, D and so on up till Z, that is 26 such characters. Then we have A, B, B, C, C and so on up till Z, Z, that is 52 such characters, 26 into 2. And similarly, we will get 26 into 3, which is 78. A, B, B, B and so on. Now we are given Q queries, and each query we will be given L and R. Now we need to find the number of vowels from L to R. Now let's say F R is the number of vowels from 1 to R. Then we can answer our query by F of R minus F of L minus 1, because F of R will contain the vowels from 1 to R, and we will subtract the number of vowels from 1 to L minus 1, and this will give us the number of vowels from L to R. Now the only thing we need to think is, how do we find the number of vowels from 1 to R? So we need to find F of N. That is the number of vowels from 1 to N. So first thing to observe is, let's treat each of this as blocks. So we have a block of 26 first, then a block of 52, then a block of 78, and then we will have a block of 26 into 4, which is 104. And it will contain A, that is A 4 times, then B 4 times, B, 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 and so on. So we need to find that how many blocks, complete blocks, lie before N. That means if, let's say, N was 79, then it will contain the first 2 blocks completely. It will contain the first 2 blocks completely, and then the third block partially. Because the sum of 26 and 52 is 78, then we will have one character of this block. So let's find the number of blocks which lie completely before N. So for 79, we will have 2 blocks. Now, let's say there are k blocks which lie completely before. So the total sum will be 26 into 1 will be the first block, then 26 into 2 will be for the second block, then 26 into 3 will be for the third block, and for the final block we will have 26 into k. Now this should be less than or equal to N, because they lie before N. So from here we can write this as k into k plus 1 by 2, because this is the sum of natural numbers. So we get 13 into k plus 1 should be less than or equal to N. Now we can find k using binary search. That is, we check the middle value. If the middle value satisfies this condition, we will look for higher values. If the middle value does not satisfy this condition, we will look for lower values, because we need to find the maximum k which satisfies this condition. Also, we can find this using quadratic equations as well. So this is 13k square plus 13k minus n less than or equal to 0. So the maximum root, so if the curve will be like this, so we need to find the maximum k such that this value is negative. So the maximum k will be the maximum root, and since k is an integer, we will consider the closest integer to the maximum root. So let's find the root. So k will be let's say this equation is ax square plus bx plus c, so minus b is 13, plus, because we need to find the maximum root, so we will take plus, under root b square is 169, minus 4ac, so minus 4 into 13 into minus n, so this is 52n by 2a, a is 13, so this will be 26. So we get this k, so this k is the number of blocks which lie completely. Now, out of this 26 characters, we have 5 vowels. So, we can initialize our answer as 5 into k plus 1 by 2. So, for example, if n was 79, then using this equation, we will get that k is 2. That means we have 2 blocks. As you can see that 26 plus 52 is 78. So, we have 2 blocks. So, the number of vowels in this 2 blocks will be 5 into 1 plus 2. That is 5 into k plus 1 by 2. Because in the first block we have the characters from A to Z. That means we will have 5 vowels. Then we have characters from A to Z and each character occurs twice. So we will have 5 into 2, 10 vowels. Now we will subtract 26 into k plus 1 by 2. That is 13 into k plus 1 from n. Because we have already considered these number of characters. So for this case, we will subtract 26 into 1 plus 2. That is 78, because we have already considered the first 78 characters. So we are left with one character and we need to consider one character from here. So in the general case, we need to consider n minus 13 into k plus 1 characters. But now we will have groups of k plus 1. So for this case, since k was 2, we will have groups of 3. We will have 3a's, then 3b's and so on. So since we have groups of k plus 1, and we know that we won't move outside of this block because this is a partial block. Our string ends somewhere in this block. So I'll iterate over the characters from A to Z. That means we'll iterate from 0 to 25. And we will either subtract k plus 1 from n, because we have k plus 1, A's, then k plus 1, B's and so on. Or if n is less than k plus 1, we'll set n to 0. That means we'll subtract minimum of k plus 1 and n from n, and that will give us the number of characters. So for example, we are left with one character and k is 3. That means k was 2 and k plus 1 is 3. So k is 2 and k plus 1 is 3. So we'll subtract one character from minimum of 1, 3, which is 1. So we'll subtract one character. And we know that the first character is A. So we'll add 1 to our answer. So we'll iterate from 0 to 25. We will subtract minimum of k plus 1, n characters. And if the character is a vowel, we will add this value to our answer as well. So here we added, we had 15 initially and we added 1 to our answer. So the number of vowels less than 79 or 16. So in this way we can solve our query. Now let's look at the code to understand more clearly. So we iterate over the queries and we push back query of r minus query of l minus 1. So answer is query of r minus query of l minus 1. The only thing we need to find is how to find query of n. Now this r is the k which we talked about. So r is square root of 169 plus 52n minus 13 by 26. So as you can see here, k was square root of 169 plus 52n minus 13 by 26. Now we initialize our answer as 5 into r plus 1 by 2, because we have r complete blocks and each block will, first block will give us 5 vowels, then second block will give us 5 into 2 vowels and so on. Rth block will give us 5 into r vowels. We subtract 13 into r plus 1 from n and we increment r by 1. That means now our blocks will be of size r plus 1. Now we iterate from 0 to 26. We set d as minimum of r n and we subtract d from n. So d is the characters that we can take. So we have first RAs, then RBs, then RCs and so on. So for example, if R was 4 and we can take 6 characters. So we will be able to take these 4 characters completely and we can only take 2 Bs. So if you use this logic here, R is 4. Now we take D as minimum of r, n. So here we will take 4 characters. Now we will subtract 2 from n, 4 from n. So we set n as 2. Now we take minimum of 2, 4, that is 2. So we take 2 characters only because we cannot take more than 2. So if I is equal to 0, 4, 8, 14 or 20, that means it is a val. We'll increment our answer by d and finally we will return answer. Now, what about the time complexity? So for each query q, there are q number of queries. We just have a loop of O of 26. So the time complexity is q into 26. So I hope this was clear to you. In this video, I will describe the easy problem and the hard problem of strings. So let's look at the easy problem, flipping string. You are given a numeric string A which consists only of zeros and ones. You have to find a range such that if we flip all the elements within the range, we get the largest substring of contiguous ones. Return the length of the largest substring of contiguous ones after flipping exactly one substring. Note that given string always contains at least one zero. Now the length of A is of the order 10 to the power 5. So let's look at the first sample. A is 0, 0, 0. So we could just flip the entire string and we will get 1, 1, 1. So we get a contiguous substring of length 3. For the second case, 1, 0, 0, 1, 0. We could flip the zeros from second to third index. So we will get 1, 1, 1, 1, 0. So we get a contiguous substring of length 4. So let's look at the solution outline. So one thing you can observe is it is always beneficial to flip a substring which consists only of zeros. So for example, we have 0, 0, 0, 1, 1, 1, then 0, 0, 0, 0, and then some 1, then 0, 0, then 1, and so on. So if we flip a substring which contains a 1, then we will be converting some ones to zeros. So it is not a best case. We could instead flip all of these 4 zeros to 1 and we will get a better answer. So the idea is simple. Let's keep the running length of zeros and ones. So for example, here we have zeros and 3 zeros. Then we have ones and there are 3 ones. Then we have zeros and we have 4 zeros. Then we have 1. We only have 1, 1. Then we have zeros and 2 zeros. Then we have a 1. So the idea is simple. Just iterate over this running length of zeros and ones. So if we get a 0, we will try to flip it. And since we flip it, the adjacent elements will form a contiguous substring of 1 as well. So if it is a 0, we will flip it and take the adjacent elements contribution to our answer. If it is a 1, we can just take it as it is. So for example, we have a 0. We will flip it. So we get 3 ones. Plus we have 3 adjacent ones as well. So 3 plus 3. We don't have anything to the left. So we'll ignore it. So our current answer is 6. Now we get a 1. So let's ignore 1 because we will never flip a 1. Also, since we have to exactly 1 flip, so we can ignore the cases where we have 1s. Now we have 4 zeros. So we will flip this substring. So we get 4. Now let's look at the number of ones to the left. So we have 3 ones to the left and we have 1, 1 to the right. So 4 plus 3 plus 1, which is 8. So now we update our answer as 8. Now we have a 1. So let's move to this. So we have 2 zeros. So we will flip this 2 zeros to 1s and then just add the number of ones to the left and number of ones to the right. So we get 4 here. So we'll ignore this because our current answer is 8. Now for the final case, 1, 1, we'll ignore because it is a 1. So we can say that the maximum answer will be 8. So let's look at the code and implementation to make it more clear. So we actually store a pair of integers just like we stored here. The first number will be the number if it is a 0 or 1 and the second will store the running length frequency. So the way we store it is by using 2 pointers. So we initialize I as 0. So let's actually try to do this in this example as well, which is 0, 0, 0, 1, 1, 1. So 0, 0, 0, 1, 1, 1, 1, 0, 0, 0. Okay, so let's just do it for this substring. So initially we initialize I as 0 and while I is less than the length of the array. That means if we have processed the complete string. So you initialize j as I. So j is the pointer which will move to the next if the characters are equal. So we check if j is less than a dot size and aj is equal ai. So currently I is here and aj is equal ai. So we'll move j here. Now again aj is equal to ai. So we'll move j here. Again aj is equal to ai. So we'll move j here. And now aj is not equal to ai. So that means we are done. So currently I is here and j is here. So the difference between I and j will give us the running length. So we push back a pair where the first character is ai minus 0. That means it will be 0 if this character is 0 and 1 otherwise. And now the frequency will be j minus I. So if we consider 0 indexing, there is a 0, 1, 2, 3. So the frequency of zeros will be 3 minus 0. After doing that, since we have processed these first 3 characters, we will move I here. And then we will keep on doing that. So we will again initialize j as I. Now aj is equal to ai. So we move j here. Again aj is equal to ai. So we will move j to the next character. Again aj is equal to a, so we'll move j to the next character. Again aj is equal to a, so we'll move j to here. And finally, we will add the difference of these 2 pointers, which is 4. So we'll add 4 here. And after doing that, we will assign I as j. So now I will be at this 0. Now we assign j as I. So aj is equal to a, so we move j to the next character, again aj is equal to ai, so move j here. Again aj is equal to ai, so we move j to the outside of the array, but once we move j to the outside of the array, we will break because we have a condition that j is less than a dot size. Now finally we will append j minus i to our vector as frequency and 0 as a character, and finally we also assign I as j, so we'll move I here, but since I is outside of this array, we will break. So in this way we can find the running length of zeros and ones. You can use any other method as well. So now we treat over the vector of running lengths. If vi dot first, that means the character is 1. If the character is 1, we can simply say that the answer is the frequency, or we can actually ignore it as well, since we have at least one 0. Otherwise, we will flip this if it is 0. If the current sequence is 0, then we will flip the complete substring. So the frequency is vi dot second, and finally we will have some adjacent ones, or maybe we may not have some adjacent ones if it is the left, or if it is completely on the left or completely on the right. So we'll check if we have a left, that means I is not 0. If we have a left, we will add vi minus 1 dot second, otherwise 0. If we have a right, that means I is not equal to v dot size minus 1, that is n minus 1, the last running length. Then we will add vi plus 1 dot second, otherwise we will add 0. And finally we'll keep the maximum of all such values and we will return the answer. So in terms of time complexity, this will be O of n. Since you can see that both I and j pointers move at most O(n) times, and finally this is just iterating over the vector, which will be O(n) in the worst case. So the time complexity is O of n, and in terms of space complexity, we can also say that it is O of n, since we are just keeping a vector. So let's move to the next problem. Michael is working on a very basic text editor. Initially, nothing is written on the editor. Also, the editor stores a buffer which is initially empty. In one operation, Michael can do one of the following operations: append any lowercase English character to the current string on the editor. After this operation, the buffer becomes empty. If anything was stored in the buffer previously, copy the current string on the editor to the buffer. Not that the complete string gets copied. You can't copy a string partially. Any previously stored string in the buffer is replaced. Append the string in the buffer to the current string. Not that after this operation, the buffer is still intact. You are given a string A. Michael needs to find the minimum number of operations required to write the string A on the editor. And the length of A is of around 5 into 10 to the power 5, the maximum case. So for example, if the string is AB, 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 AB. So we have 6 ABs. So one of the ways, first we append A to the editor, the current string is A, current buffer is empty. Then we append B, so current string is AB, buffer is empty. Then we copy the string to the buffer, so current string is AB, current buffer is AB. Then we append the string in the buffer to current string, so current string is AB, AB, and the current buffer is AB. Again, we do the same thing, that we append the current buffer to the current string, so we get AB, 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 and the current buffer is AB. Then we copy the string to the buffer, so current string is AB, 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 and the current buffer is also AB, AB, AB. And we append the string in buffer to current string, so current string is 6 times AB, and the current buffer is 3 times AB. So finally we have formed the strings and we required 7 operations. So in this way we need to find the minimum number of operations. So let's look at the solution approach. So let's try to find the answer for one string A, B, A, then B, then again A, and then B. So the idea is we will find the answer for the prefix. So answer I stores the answer from 0 to I. So if we number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So answer I stores the answer for the prefix from 0 to I. So for example, answer 4 will store the answer to form this string A. So one thing that we can obviously write it, let's consider the first operation. So the first operation is append the character. So you can see the first operation is append any lowercase character to the current string on the editor. If we use this operation, so we can write answer of I as 1 plus answer of I minus 1. Because let's say we have formed the string from 0 to I minus 1, we can just add the lowercase character, that is character at ith index, and we will form the string from 0 to I. So this is one of the operation. Now the second operation is we can copy the current string to the buffer, and after copying we can append the buffer to the current string. So let's look at second and three operations now. Now one thing to notice is, if let's say we have a string S1 to S3 and then we copy this string to the buffer, so when will it be beneficial to append it? If our string is something of this form, S1 to S3, then again it has the same characters S1 to S3 and again S1 to S3 some number of times. That means the current prefix can be represented as concatenation of smaller strings. So for example, our complete string can be represented as concatenation of AAA, and again AAB. So what we can do is, after forming this string, we can copy this string to the buffer and append the buffer to our current string. So in two operations, we will be able to double our string. And similar way, if let's say our string was again we had some 6 times A and B, and we could have done one more append operation and we would have been done with forming the string. So you can actually think of the second and third operations together, that if our string is periodic. So by periodic, I mean it can be represented as sum of concatenations of smaller strings, then it will be beneficial to use third operation. But one thing to notice is that we can actually have multiple operations. That means the string could be divided into multiple parts. So for example, if the string is AB, 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 and AB, then we could have formed AB and then copied it and pasted it 3 times. So we would have 4 operations for pasting. Or we could have formed AB, AB, and then that is copied it once and pasted it once. So we'll have AB, AB, and AB, AB. So we have multiple such ways. So how could we choose that which way is the better? Well, it's simple, try them all. So the only thing now is to find the period of the string. So period of the string is the smallest length. So period of the string S is the smallest length string T, such that S can be written as concatenation of one or more copies of T. So for example, ABC, ABC, and ABC, period will be 3 because we can write S as ABC plus ABC plus ABC. And there is no smaller string T using which we can represent S as copies of T. So for A, the period will be 1 because we can represent S as copies of 6 A's. We could also represent it as copies of 3 A's, but the smallest length is 1. So the period is 1. So from here you can notice that if we know the period of the string, so for example, this period is 3, and then we can write it as TTT, where T is ABC. So we can break it, we can club it in divisors of 3. So let's take a different example to make it more clear. For AB, 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 we know that the period is 2 because we can write it as 4 copies of T. So let's say we can write it as TTTT. So finally, we can say that we can either club 2 T's or we can only take 1 T and so on. So we could say that we could form T and then use a copy operation and 3 paste operations, or we can say that we can form TT and then use 1 copy operation and 1 paste operation. But how do we know the answer for forming TT? Well, that would have actually been stored since we are processing from 0 to n-1. So we are going from 0 to n-1 and finding the answer for some prefix. So the only thing left is to find the period of the string. So how do we find the period of the string? So here we can actually find the period of the string using prefix function of KMP. So prefix function actually is some value stored for a string. So for ANA, if its indexes are 0, 1, 2, 3, 4. So for each index I, it considers the prefix from 0 to I. So consider the string ANA. Now it finds the largest prefix, which is also a suffix of this string. Largest proper prefix. So by proper prefixes, we cannot take the complete string. So for example, this value will be 1. So because the largest prefix, which is also a suffix of this string, is A. So the length is 1. So it stores the length of the largest prefix, which is also a suffix. So let's actually find the prefix functions for each index here. So for 0th index, it will be 0 because we do not have any proper prefix. For AN, it will again be 0 because we do not have any proper prefix, which is also a suffix. For 0, 1, 2, for ANA, it will be 1 because A is both a prefix and a suffix. For AN, this will be 2 because for AN, 2 is the largest prefix, which is also a suffix. So AN is the largest prefix, which is also a suffix of the string, and the length is 2. And for ANA, it will be 3 because ANA is the largest prefix, which is also a suffix of this string. So ANA and ANA. So this will be 3. And I'm not going to actually describe how we find the prefix function, but this can actually be found in O of n. So if you don't know how to find prefix functions in O of n, you can read it online about KMP. So it's used in string matching. But I will describe, given the prefix function values, how do we find the period of the string? So you can think that if S is some copies of T, we need to find the smallest length T, right? So what will be so let's say if this length is P, the period of the string, that is P is mod of T, length of T. So what will be the prefix value for the last index? So we know that prefix value is the largest prefix, which is also a suffix. So we can say that the answer will be this, the longest prefix, which is also a suffix, will be this. So if the length of the string is n, what will be the value of prefix function? Let's call value of prefix function as pi. So pi will be n minus mod of T. You can see that pi will be n minus mod of T. So n minus P. So you can find the period as n minus pi. So for example, for AB, indexes are 0, 1, 2, 3, 4, 5. And let's find the prefix value. So it is 0. Again, this is 0. Then this is 1 because it has a common prefix and suffix a, then it will be 2 because ABA is the longest prefix which also suffix. Then it is 3 ABA and ABA, and this will be 4 ABAB and ABAB. So ABAB is both a prefix and a suffix of the complete string. So as per our formula, period will be n, and the length of the string is 6 minus pi. Pi is the prefix value of the last index, so it is 4. So the period will be 2, and we know that the period is 2 as well. But there is a catch. We know that the period should be divisible by n. So we also have to check if n modulo p is equal to 0. If n modulo p is equal to 0, then p will be a period. Otherwise, the period will be n. So for this case, take this case, a and a and a, the length is 5, n is 5, and the prefix function value of the last index is 3. So period should be 2 as per our case. But we know that the period should be divisible by the length of the string, should divide the length of the string. And 2 does not divide 5. So the period is actually 5. So that means we will have to take t as a complete string. And you can see that the period is 5 in this case. So now we know that how to find the period of the string. So how will this help us? So since we are calculating the prefix function for each index, we can actually find the period for every prefix, because all we need is the prefix value at that index, pi value at that index, and we can actually find it quite easily. So let's find the prefix value for this string. So let me drag it down, and we will write the prefix value for this string. So here it will be 0, then this will be 1 because AA, and then this will be 2, AA and AA, then this will be 3, AAA and AAA, this will be 4, this will be 5, and then this will be 0 because we don't have any prefix which is suffix. Then this will again be 1, then 2, then 3, then 4, then 5, and then 6, and then this will be 7 because we can say that 6 times A and B is the longest prefix which is also a suffix, longest proper prefix which is also a suffix. So once we found this prefix values, let's actually calculate the answer. So answer of 0, so we can say that answer of 0 will be 1 because to form one character, we will use the first operation and append. Initially the string is empty, so we'll append this character. So answer of 0 is 1. So let's actually store the answer table as well. So answer of 0 is 1. Now we need to find answer of 1. So we can initialize answer of 1 as 1 plus answer of 0. So answer of 0 is 1. So we can initialize answer of 1 as 2. Now we'll check if we can reduce answer of 1 using second and third operations. So let's first find the period of the string. So for this prefix 0, 1, the length is 2 and the pi value is 1. So the period should be 2 minus 1, 1, and 1 actually divides 2, so period is 1. So now that we know the period, we know that it could be written t plus tt. So the only way we could divide is in 2 copies. So we will require 1 copy operation and 1 paste operation. So it will be 2 plus, now the length of t is 1, so 2 plus answer of 0. Because the length is 1, so the next will be 0, and answer of 0 is 1. So here we get 3. But we know that it does not actually reduce our answer, so answer of 1 will be 2. So similarly, let's find answer of 2. So answer of 2 will be 1 plus answer of 1, which is 2. So we can initialize it as 3. Now we will check if we can reduce it further. So from here you can see that the period will be 1. You can use the same method to find the period. So the period will be 1. It will be something like TTT. So again we could divide it into 3 parts. That means we will just iterate over the divisors of 3. Obviously we won't take 3 because that would mean that we are just taking the complete string. So we will take 1. So we'll require 1 copy operation and 2 paste operation. So answer will be 3 plus the number of operations required to form t. And the length of t is 1, so the number of operations required to form 0. So answer of 0 is 0. So this will be 3 plus 1, 4. And we know we won't update it because our current answer is 3. So now we'll move to the next third index. So again, we'll initialize answer of 3 as 1 plus answer of 2. This will be 4. Now you can find the period of the string. So this length is 4 and the prefix value is 3. So the period will be 4 minus 3, 1, and 1 divides 4. So we could write it as TTTT. Now the multiples of 4 are 1 and 2. Proper multiples, that means not equal to itself. So they are 1 and 2. So we could either divide it into 4 parts, TTTT, or we could divide it as TT and TT. So let's first actually find, if we divide it into 4 parts, what will be the answer? So we'll require 1 copy operation and 3 paste operations. So 4 plus answer of 0, and answer of 0 is 1. So this will be 5, and it does not actually reduce our answer. So let's try this TTTT. So this will be, we'll require 1 copy operation, 1 paste operation. So 2 plus, now we will form string of length 2 because t is equal to a. So string of length 2, which is answer of 1. So and answer of 1 is 2. So this will be 4. And the current value is also 4, so we don't need to update it. So now let's move to the next index. We have AAAAA. Now again the period is 1. So we could write it as TTTT 5 times. And again we need to divide it into 5 parts. So we'll require
5 plus answer of 0, which is 6. But we could also write answer of 4 is 1 plus answer of 3. So this would be 5 again. Now let's find answer for 5. So we could initialize it as 6. That means 1 plus answer of 4. So 6. But now let's try to check if we can divide it. Again, the period is 1. So it is 6 times t. So we could either divide it into 6 strings, or we could club 2 t's, or we could club 3 t's as well. So we will consider each of the case. So what if we divide it into 6 parts? So the answer will be 6 plus, because we will require one copy operation, and then we will need to paste it 5 times. So 6 plus answer of 0, which is 1. So answer of 0 is 1. So that will require 7 operations, and the current answer is 6. So let's try this possibility where we divide it into 3 parts. So it will be 3 plus answer of 1, because tt is a. So prefix of length 2. So, and we know that the answer of 1 is 2. So this will actually require 5 operations. So we update our answer as 5. Now let's try this possibility. So it will be answer of 2 plus 2. So 2, 1 copy and 1 paste, plus answer of 2. And answer of 2 is actually 3. So again, this is 5. So now this answer will be 5. Now for this index, answer will be 1 plus answer I minus 1, that is 6. Now let's actually find the period of the string. And as you can see, the period of the string is n. So we cannot divide it. So we move to this index. Again, answer will be 1 plus answer of I minus 1, that is 7. And since the period is n, so we'll move to the next index. So this will be 8, 9, 10, 11, 12. Because the period of all the parts are n only. So we cannot further divide it because it is just a single t. Now for the complete string, let's find the period. So period will be length is 14 minus pi value. So pi is 7. So the period will be 7. And since 7 divides 14, so we can say that the period is 7. And we can say that it can be divided into 2 copies tt. So first we will initialize our answer as 1 plus answer of 5 minus 1, that is 13. And now we will check if we can further reduce it by dividing. So the answer will be, we will have 1 copy operation and 1 paste operation, 2 plus answer of length of t minus 1. And the length of t is 7. So we will initialize our answer as 2 plus answer of 6. So answer of 6 is 6. So this will be 2 plus 6, which is 8. So we will finally update this as 8. So the last value will actually contain the minimum number of operations to form the complete string. And we can say that we will require 8 operations to form the complete string. So let's actually look at the code, and you will realize that what is the time complexity and how do we implement it. So Sieve actually stores the divisors of all the numbers from 1 to n. So we'll iterate from 1 to n, and then we will move over all the multiples of n. So for j equal to I, j less than n, j plus equal to I. And finally, we will append I to the factors of j. So the time complexity of this will be n log n, because when I is equal to 1, we will do n by 1 operation. When I equal to 2, this loop will run for n by 2, and when I equal to n, this will run for n by n. So this is actually sum of harmonic series. If we take n as common, and the sum of the series is n log n. So we can find factors of all the numbers from 1 to n in n log n. Now, this pi actually stores the prefix function of the string s. So I'm not going to describe how the prefix function works. And we initialize answer of 0 as 1. Now we'll iterate from 1 to n minus 1. We initialize answer of I as 1 plus answer of I minus 1. And now the length k is the period of the string, and I plus 1 is the length of the current prefix, and we subtract the pi value. So if I plus this period k is not divisible, then our period will be I plus 1 only. So in this way we found the period. So since our period is k and the current length is, so the length of t, so we're writing s as copies of t. So the length of t is k here. And now C actually stores how many copies it gets divided into. So for example, for AB, we get the period as 2, p is 2. So we can divide it into 3 copies of t. So C actually stores, C will be 3 in this case. C actually stores how many copies, maximum number of copies we can divide our string into. Now we will just iterate over the factors of C, because let's say if it can be divided into 6 copies, if it can divide into 6 copies, we can either form t and then use 1 copy operation and 5 paste operations, or we can form tt and then use 1 copy and 2 paste operations, or we can form ttt and use 1 copy and 1 paste operation. So we have the number of possibilities as factors. Obviously we won't take the maximum factor, so if j equals 0, C we will break. Otherwise we will find the contribution of this division. So we know that this length is k. So if we take j copies, if we take
club j copies, for example, if j is 3, we will have a string of length 3k or j into k. So we already know the answer for this prefix will be answer of 3k minus 1, that is answer of k of j minus 1. And the number of operations required will be, so here c was 6, that means we have 6 copies. And if we club 3, the number of operations required will be 6 by 3, that is 2, because we will require 1 copy operation and 1 paste operation. So we add c by j, and finally we will return the value stored at the last index, answer of s dot size minus 1. So now let's think about the time complexity of this operation. So prefix value can actually be found in O of n. Now, for each index, we iterate over the divisors, but that will be at most O of n log n. And the space complexity is O of n. So I hope this video was clear to you. Thank you for watching this video.
Everyone. So my name is Kshitij and I will be discussing about arrays in today's class. Okay. So in today's class, we are going to discuss some challenging problems on arrays, which can be solved just by the knowledge of arrays. In tomorrow's class, we'll be discussing some more challenging problems on 2D arrays, and then in the upcoming classes, we'll be discussing about sorting. Okay. So in the next 4 or 5 classes, we'll be discussing about arrays and sorting algorithms. Okay. So before we start the class, I just want your opinion on have you guys ever worked with arrays? Have you guys ever used arrays? Are you guys familiar with what is an array? Arrays are nothing but collection of same type of data, right? You can have an array of integers, you can have an array of strings, you can have an array of floating point data structure, or you can even have an array of objects, right? So array is nothing but a collection of data, and arrays, all the values in the arrays are stored in continuous memory locations, right? So if you have an array A of size 5, and if this is your memory, all these array elements are going to be stored in continuous memory chunks, right? So they are always in a sequence. Correct. Homogeneous collection of data. Absolutely correct. Okay. Now, in today's class, we are going to see some of the problems which do not require any algorithm, which do not require knowledge of any other data structure other than arrays. Okay. And these problems have been asked in Google, they have been asked in Facebook, they have been asked in Amazon. So if you are just familiar with arrays, and if you have a basic logic building or problem solving skills, you can attempt these problems. Okay. Right. So regarding the language, so most of you are asking in which language are we going to discuss the problems, right? So let's keep the session language agnostic. Okay, we'll be discussing the logic, we will be discussing the pseudocode, but all the logics that we are going to discuss, they will be language agnostic. So whether you are coding with C, C++, Java, Python, Ruby, doesn't matter. You can apply those logics, you can apply the same solution in any language. Okay, so keep things language agnostic, and let's focus on the problem solving techniques. Okay, one more thing guys, that with the class you will also be getting the problems that we are going to discuss. You will get the exact same problems, you will also get some variations of these problems. Okay, so that you can test your knowledge there, right? So I strongly recommend all of you to attempt those problems, because if you are just listening in the class and you feel that you have understood everything, you might understand things, but after a while you will forget. So it's always better to reinforce your knowledge by practicing those problems. Okay, so I will strongly recommend you guys to solve all the problems which are provided in the description link. Okay, cool. So let us start this session with a very interesting problem, and this problem was asked in Amazon. This has been asked in Facebook. This has been asked in Google. Okay, the problem says that you are given an array, and in this array you are having heights of some buildings. Okay, so you can consider that these are 2D buildings, 2-dimensional buildings with a width of size 1, and the height is given to you in an array. Okay, so let's say that this is the array in which you have all the heights of the buildings. Okay, now you can see this picture. So these are the buildings, right? And these black bars are the buildings, and it's raining heavily in this city. So you have got some clouds and it's actually raining heavily, and because of the rain there is some water which is being trapped between the buildings. Okay, so these are the clouds, not so good looking clouds, but yes, there are clouds, and you can see some water being trapped in between the buildings. So given the heights of the buildings, you have to identify what is the total amount of water which is being trapped in between these buildings. Okay, is the problem making sense? तो आप लोगों को एरे में बिल्डिंग्स या बार्स की हाइट दिए हुए हैं, एंड वहां पे शहर में बहुत तेज बारिश हो रही है, तो चूंकि ये 2 डायमेंशनल वर्ल्ड है, यहाँ पर कुछ वाटर ट्रैप हो रहा है इन बिल्डिंग्स के बीच में. ओके, आपको बताना है कि टोटल कितना अमाउंट है वाटर का जो कि ट्रैप हो रहा है. ओके, राइट, दिस इज अ वेरी वेरी फेमस प्रॉब्लम. इट इज कॉल्ड ट्रैपिंग रेन वाटर. This is a problem which is present in each and every platform. This is in LeetCode, this is in InterviewBit, this is in Geeks for Geeks, this is in HackerRank. This is present in each and every platform because this is very very frequently asked problem, right? So what is the answer for this case? Here we can see that 6 unit of water is being trapped, right? 1 unit here, then you have 1 unit here, 1 unit here. So let's actually draw the squares, right? This is 1 unit of water. Then you have 1 unit of water here. Then you have 1 unit of water here, 1 unit here, 1 unit here, and 1 unit here, right? So you have got 6 units of water being trapped between these buildings here. Okay. Now the question is that given the array, you have to identify, you have to calculate the total amount. Okay. How to approach this problem? Okay. So there is focus on what is contributing to the total amount. How do we calculate the total amount? So how have we counted the total amount of water in this case? To count the total amount of water, what have we done? We have just counted what is the amount of water trapped above each and every bar, right? So if I count what is the total amount of water trapped above each and every bar, and if I just add that, that would be the answer. For example, here this bar length is 0, so this bar is having 0 amount of water trapped. Here the bar length is 1, but even then the amount of water trapped above it is 0. Here the amount of water trapped above this bar of length 0 is 1. Right? Similarly, here we have 0 amount of water. Above this bar we have 1 unit of water, right? Similarly, above this bar we have 2 units of water. Here we have 1, then again 0, 0, then 1, 0, and 0. So if we just add all of these, we'll get the answer. If we just add the amount of water or the size of the water column trapped above each and every building, we get the answer. Now the question is how to get the amount of water trapped above each and every bar, right? So we have reduced the problem from finding the total amount of water to count what is the amount of water trapped above each and every bar. But how to do that? Okay, again, let's make some more observations here. Okay, so we have seen that the amount trapped above this bar is 0. Okay, why is this amount 0? Why is it not non-zero? Why is this amount? Why is this bar not able to trap any amount of water above it? Simple reason is that there is nothing on the left side to hold the water, right? There is something on the right side, but if the water falls here, there is nothing on the left to hold it, right? If there had been a bar on the left side, then you would be getting some water here, but there is nothing on the left side. So you can just consider this as a vessel which is of this L shape, right? You can consider this scenario as a L-shaped vessel. If you fill any liquid inside a L-shaped vessel, it will just flow from here, right? You cannot trap the liquid in a vessel which does not have the boundary, right? So that's why here we have 0 amount of water. Now, what about this bar? This also has 0 amount of water. What is the reason for that? This is not 1. This has to be 0. What is the reason for this? Again, the same reason. this bar also does not have anything on the left side to hold the water, right? That's why this is also not trapping anything. When we come to this bar has got a size 0, but it is able to trap a water column of height 1. Simple reason being, it has got something on the left and something on the right as well. So now this is forming a complete vessel, right? So it can hold water, a water column of size 1. Now we come to this bar again. This has got a bar which is on the left side, right? If I'm talking about this bar here, this has got a bar on the left side. Even after that, this bar is not able to hold any water. Why? Because the bar which we have on the left side has got a smaller height, right? If you have to hold some water above this bar, you need something on the left and something on the right of a higher height, right? So you can assume that this is the surface of your vessel. Now this bar here is below the surface, right? So you need something which is higher the surface. Then only you can trap some water inside this, correct? So that is why this is also not able to trap anything. Now when you come here, this has got something on the left and something on the right as well, correct? So one thing which is very clear from this observation is that to trap the water, you definitely need something on the left side, something on the right side of a higher height than the current bar, right? This bar is not able to trap because it doesn't have anything on the left. This bar is able to trap because it has a support on the left side as well as on the right side. So it has got both the boundaries, correct? Cool. Now the question is, how do we? So we have determined that some of the bars will not be able to hold, but the bars which are holding the water, how much water is going to be there? Okay. Now to do that, to actually analyze that, let's consider a very simple example first. Okay. So let's say that the heights of the bars are 2, 1, and 3. So we have got a bar of size 2. Then we have got a bar of size 1, and then we have got a bar of size 3. And we are talking about this middle bar. We have to identify what is the amount of water being trapped above this middle bar. Okay. This has got height 2, this has got height 1, this has got height. Can you guys quickly respond? What is the amount of water which will be trapped above this bar? The size of the water column here. Is it going to be 1? Is it going to be 2? Is it going to be 3? It's going to be 1, right? Why 1? Because the height on the left side is this height is of size 2, right? And we have this bar till height 1. So the only limited space that we have for the water is this column. Anything above it will flow from here, correct? Okay. Let's change the example. Let's add some more bars here. Okay, so initially we have this configuration where we have bar of size 2, 1, and 3. Now I'm going to add one more bar on the left side, and this bar is also of length 3. Now how much water will be trapped above this bar? Is it still going to be 1, or now will we have some more water here? Yes, it's going to be 2 this time. Why? Because now we have got a higher support on the left side, right? So if it is continuously raining, all this area will be filled with water, right? And now we can see that this column, the height of this column has now become 2, right? The height of the water column trapped above the above this bar has now become 2. Height of the water column above this bar has now become 2. Okay, why has it become 2? In this case it was 1, now it has become 2. What is the reason? The reason is the addition of this bar, right? Let's add some more bars. Okay, let us add some more bars to this configuration. So I will be adding a bar on the left side. Let's raise a bar of size 4. Will the height of the water column stored above this will increase? If I have just added a bar on the right side of length 4, will the height of the water column above this bar, is it going to increase? No, right? because on the left side it is still 3. On the left side, the maximum that we can have is still 3. Anything above it is going to flow from here. If we also add another bar of size 4 on the left side as well, now will it increase? Yes, now it's going to increase because from both the sides we have got a height of size 4, right? So is this complete observation making sense to you guys? The height of the water column stored above any height is nothing but the minimum of the maximum height that you can get on the left side and the maximum height that you can get on the right side. Correct? The height of the water column stored above this is minimum of maximum height available on right and maximum height available on the left. So if I have to identify what is the height of this column, right? Height of water column above bar I, this is equal to, this is nothing but the minimum of maximum bar on left side, maximum bar on right side, minus the height of bar I. So if I'm talking about, if this is my ith bar, the water column trapped above this bar is how much? This is minimum of maximum of left, maximum of right, minus the height of this current bar. If I have to calculate the total amount of water, this is just going to be the sum of all such values. Correct? So the answer that we are going to calculate, sum of this value for each and every height, right? Sum of minimum of left max, right max, minus height of bar. So I will be calculating the minimum of left max, minimum and right max for each and every bar, subtract the height of that bar and keep adding it. So whatever we get at the end is going to be the answer. Correct? Let's quickly do this thing on the given example. Right? What is the minimum? What is the minimum on the left side for this? Minimum on the left side for the first bar is 0. There is nothing on the left. Sorry, maximum on the left side, right? Maximum on the right side is this bar of length 3. But since we are taking the minimum of left max and right max, minimum becomes 0. 0 minus the height of the bar is 0, right? So this is not going to hold anything. What about the first one? Again, left max is minimum. Left max is 0. So we won't be getting anything, right? For this bar, for this water column, the left max is 1, right? The right max is 3. So minimum of left and right is 1 minus the height of this bar, which is 0. So this is going to hold 1 unit of water, right? So if we do the same thing for each and every bar, we are going to get the answer. Let's also see for this column. So here, what is the left max? Left max has got a height 2. Right max has got a height 3. Minimum of 2 and 3 is 2. Right? So this bar is going to hold 2 minus the height of this, which is 0, this much amount of water. So we just have to do this thing for each and every bar, and we add whatever amount is trapped over that bar, and we get the answer. Okay. Okay, let's do this in this example. Let me just clean it up a bit. Let's try to calculate what is the total amount of water that will be trapped in this scenario. Okay, if this is the landscape of the buildings that we have, what will be the total amount of water trapped here? Okay, so we are saying that the total amount of water trapped is the sum of water trapped above each and every building. What if negative? Heights are not going to be negative, right? Negative height means that you are digging a hole and then you are, so it's basically kind of a plane. So you can assume that such buildings with negative heights are not possible. Okay. Okay, let's try to run our approach on this thing. Okay, on this scenario. So for this building, what is the maximum height on left side? Maximum height on left is 0. Maximum height on right is 4. For the first building, the answer is going to be 0, right? For the second building, maximum height on right is 4. maximum height on left is 4. Maximum height on right is also 4. Right? So we'll be getting minimum of these two minus whatever is the height of the building, which is 3. So this is going to contribute 1 unit of water. Okay. Then in the next building, so the 1 unit of water comes here. In the next building, we will be checking minimum of what is the left max. Left max is still 4. What is the right max? Right max is still 4. Building size is 2. So we get 2 units of water above this. Okay. Similarly, for the next buildings, again, left max, right max are 4 and 4. Building height is 1. So we get 3 units of water above this. Okay. Similarly, we'll be doing for this as well and this as well. And once we add all these values, we'll be getting the answer. Okay. Cool. So now once this is clear to everyone, can you guys tell me what is going to be the time complexity of this approach? So for every bar, we are calculating a maximum on the left side, we are calculating the maximum on the right side, and then we are applying this observation and getting the height. What should be the time complexity if we go by this approach? Okay, let me just reiterate over this example again. For if I'm calculating for this bar, I will have to calculate what is the left maximum. To calculate the left maximum, I will be iterating over all the possible bars on the left side. To calculate the right maximum, I will be iterating over all possible bars on the right side. How much time is this operation going to take? This is going to take order n. How much time is this operation going to take? This is also going to take order n, right? So to calculate the water column above each and every bar, we are doing an order n operation because these two are going to get added, right? And we are going to do this operation for each and every bar. There are n bars in total. If there are n bars and for every bar, our calculation requires order n time complexity. What is going to be the total time complexity? Right, so there are n bars. For every bar, we are going to do order n operations. So the total time complexity is going to be order n squared. Okay, can we optimize this order n time complexity? In the last class, you must have learned that order n is not a very good time complexity, right? Yes, Vijender, you are absolutely correct. Right, guys. So to optimize the time complexity, again, let's make a very simple observation, right? So till now, we have deduced that for every bar, we have to calculate the left max and the right max. Okay. Let's talk about the last bar. Okay. If I'm talking about the last bar, then we are calculating the left max for the last bar. How actually we calculate the maximum for this? The order and operation of the maximum, of finding the maximum. How do we run it? So we will be declaring a max, right? And we'll keep updating it after visiting each and every bar. So we'll initialize a maximum value. We can initialize it with a very with maybe minus infinity or maybe a not possible or 0. Maybe we can also initialize it with the length of the first bar. Okay, so we say that currently the maximum is this, and we'll keep updating the maximum as soon as we visit all the bars in this order n loop, right? So if let's actually take a complex example. So if the bars are of size 2, 3, 1, 4, 5, 2, 1, 7, okay, 2, 9. If these are the lengths of the bars, if I have to calculate the maximum from left for this last bar, right, I will be starting from here. Okay, let's initialize the maximum with 0. Okay, so we are saying that whatever is the maximum between the current maximum and the current bar is going to become the maximum, right? So maximum is initialized by 0. When we reach here, we say that 2 is the maximum. Then when we reach here at 3, we compare this value with the current maximum, right? This is how we calculate the maximum of an array, correct? So we calculate current value of the array with the current maximum. So 3 becomes the maximum. Then we compare this 1 with the current max. Let's call it the current max. Okay. Again, 3 remains the maximum, so we'll fill 3 here. So this means that till here, till this point, 3 has got the maximum height, right? Now, similarly, for the next step, we'll be comparing 4 with 3. Okay, so this gives us 4 as the maximum, then it gives 5, and then we'll be having 5, 5 till this point. Then we get 7, and then 7 continues to here. So the maximum for on the left side for this bar is 7. Okay. Now in this process, if you have observed, what have we done? We have not only computed the max for the last bar, but we have also computed the left max for each and every bar. So if you just store all these values in an array, instead of just keeping a variable of the current max, if you just have an array and store all these values inside the array, these values are corresponding to the maximum height on the left side for each and every index. Is this making sense? Till this point, 5 is the maximum. Till this point, again 5 is the maximum. Right? Till this point, 7 is the maximum. So while you are calculating the maximum value for the last bar, you have not only calculated the maximum on left for the last, but you have also calculated the maximum for each and every index. So in a single iteration, we have the values of left max for each and every value. Okay, let me just repeat. Let's clear each and everything here. Let's do it once again. Okay, so when we have to calculate the maximum on the left for the last bar, first of all, is everyone clear that we'll be calculating the left max for each and every bar and right max for each and every bar? Yes. Now, let's talk about this guy. Let's talk about this bar. If you have to calculate the left max, you will be iterating over this part of the array, right? You will maintain a left max for this bar, and you will keep updating that left max while visiting the array, right? You will initialize a left max with 0. You will check whether 0 is greater or this value is greater, right? So you will keep updating this left max while iterating over the array. Similarly, you will do the same thing for the right max as well, correct? Now let's talk about the last element. Let's not talk about the middle element. Let's talk about the last element. When we are doing it for the last element, we are actually calculating the left max for each and every index, right? Left max till now is 0, right? Or let's call it 2 here. So we have initialized the left max by 0. We compare it with 2, we get 2 here, then we get 3 here, right? Then we get 3 again here, then we get 4 here, 5 here, 5 continues till we get a longer height, which is 7, right? And again we get 7 here. What if 9 is not present? Then also you do the same thing. If 9 is not present, you have 1 bar less in your structure. Then you will be, when you calculate the left max for the last index, doesn't matter whether it is 9 or any other number. When you are calculating the left max for the last index, you have actually calculated the left max for each and every index in this process. The only thing is that you will have to store these values. Instead of updating the current max variable, if you just store these values in the array, you get the left max for each and every index. Similarly, while calculating the right max for this index, the first index, you will be calculating the right max for each and every value. Correct? Because to calculate the right max for the first index, you will be iterating from the right side, and you will keep updating all the values one by one, right? So you start from here till now, the max is 2, then you get 7, and then 7 continues to be the max till now. Okay. So is this observation making sense? The observation is that we don't need to run this order n loop for each and every index, because when you are calculating the left max for the rightmost element, and when you are calculating the right max for the leftmost element, You are essentially calculating each and every value which is required in this calculation. So instead of running these two loops of order n on each and every index, what we can do is we can just run a single loop and we can store all the required data. We can do some pre-computation. Okay, we need two extra arrays. Yes, we will be needing two extra arrays. Let's call this array as the left max array, and let's call this array as the right max array. Okay, if we have stored these values, can you guys now tell me what will be the amount of water stored over any ith index, stored over any ith bar? If I talk about this bar, what will be the answer? What will be the amount of water stored over this bar? We need the maximum bar. We need the maximum bar on the left side of this. From where can we get it? The maximum bar on left side of this bar is here, right? We have already calculated it. The maximum bar on the right side of this bar is present here. If we are talking about the ith index, the left max is stored at left max I minus 1, and the right max is stored at right max I plus 1. Okay, you don't need to run two loops for each and every number. We can just pre-compute the left max and right max for each and every index, and using these values, now we can have a different loop and we can get these values in order 1. Okay, what if we store in the ith index itself? Will that work? That will definitely work, Anushka. You will just have to check. Like you can also store for every ith index. You can store what is the left max height at this index and right max height at this index. You will just have to calculate. You will have to this. You will have to keep check on the corner cases. Okay, if you are able to keep checks on the corner cases, then that will also work. Okay, so let's quickly see the pseudocode. Okay, so we can have a left max array. Okay, what will be the size of this array? Size of the array is going to be same as the size of the input array, because for each and every index you want this information, right? So its size should be equal to n, whatever is the size of the input array, correct? And similarly, we'll also be having a right max array, which will store the right max for each and every part. Okay. Then let us initialize these values. So we can say that left max of 0 can be initialized from the array 0. Okay, and right max of okay, let's come to the right max after we finish this, right? So we have initialized this for the 0th index. That means I'm saying that for 0th index, this is the answer. The height of the bar is the answer. Now for the remaining bars, we can just run a loop, which will start from some point, go till n, and we'll be doing it. From where should we start the loop? Should it start from 0? Should it start from any other number? Yes, the loop is going to start from index 1, because we have already filled the value on index 0, so we don't need to start from index 0. Okay, and for every index we can say that left max of I is nothing but the maximum of the previous max, which is left max of I minus 1, and the current array value, the current height. So whatever is the maximum between the current height, right, between the current height and the previous, is going to be the left max of this iteration. Okay, similarly for the next value of I, we'll be comparing this value and this value. Okay, so we have our left max array filled up. Now we'll also initialize the right max array. So for the right max array, how did we start? We started from the right side, right? We said that we are starting from here, and let's copy the array value, the last array value in the last index of the right max array, because for this value there is nothing on the right side. So we are starting from here. Okay. So right max of n minus 1 is going to be array of n minus 1. And now similarly we can have a loop which will also start from some number, go till 0, and will be, this is going to run from right to left. So that's why we are doing I minus 1. So from where should we start it? This loop will start from n minus 1. We have already filled the value for n minus 1, right? So this should not start from n minus 1. N minus 1 is some value which is pre-required to compute the value at this index. So we'll be starting from the index n minus 2. Right? To calculate the value here, we need to compare this value, which is the previously calculated value, and the current height. Okay. So let's go back here. We'll be starting this from n minus 2, and right max of I is going to be the maximum of what will come here. Yes, it should be I plus 1, because now when I'm checking for this index, I'm comparing this value. If this is index I, this is I plus 1, not I minus 1. In case of left max, we were comparing with the previous index. Now we are comparing with the next index, right? So this is going to be right of I plus 1 and the current array value. Okay. So now we have got the left max and the right max array populated. Okay, now we just have to run a single loop to calculate the total amount of water trapped. So you can have a variable water initialized with 0, and now we can run a loop, and this loop should run for each and every height. So we'll start from I equals to 0 less than n. We'll be incrementing the I with 1, and we can simply say keep adding the amount of water trapped over each and every bar in this variable. So water plus equals to, or you can also write it as water equals to water plus the, how do we calculate the height of water column? Minimum of left max, right max, right, minus the array value I. Cool. What is the time complexity of this approach? Time complexity of this is, see, first in this code, first we are populating the left max array. For each and every bar, we need what is the left max. So this is going to count order n, plus this array, this loop is also going to be of order n, plus this loop is also going to cost order n, right? So the total time complexity of this approach is order, yes, order 3n, which asymptotically is same as order n, right? Order 3n is nothing but this is same as order n, because when you calculate the time complexity, you ignore the constants, right? Edge case missed, right? So if this is just a pseudo code, okay, now you have to attempt this problem, you have to solve it on your own, and in the code which you are writing, you have to take care of all the edge cases as well. Okay, Himanshu, that is on you now, so you have to do it on your own. Okay, what is the space complexity, guys? Can you tell me what is the space complexity? We are using two arrays of size n, right? So it is going to be order n in space as well. Okay, let's do one thing. Let me just tell you the problem. Okay, this is also a very, very interesting and very frequently asked problem, which is called the majority element. The problem says that you are given an array, you have to find the majority element in that array. The majority element is the element that occurs more than n by 2 times. Okay, which means that the number of times that element is occurring in the array should be strictly greater than n by 2. For example, if this is your array 3, 3, 4, 2, 4, 4, 2, 4, 4. Can you guys quickly tell me what is the majority element in this array? N, which is the size of the array. What is the size of the array in this case? 9, right? Now, which is the element which is coming more than 9 by 2 times? Correct. Majority element in this case is 4, because 4 is occurring 5 times. Okay, 4 is the majority element here because 4 occurs 5 times. Let's take another example. Let's say we have 3, 3, 4, 2, 4, 4, 2, 4. What is the majority element in this case? Size of the array is 8. What is the majority element which is occurring more than 4 times in this case? 4 is occurring 4 times, right? But we need something which occurs more than n by 2 times. 4 is not more than 2. So in this case, we do not have any majority element. Okay? No majority element. So you have to, if there is a majority element, you have to return that element. If there is none, you can return none. Okay? This is the problem. Is the problem clear to everyone? What would be a brute force way to solve this problem? What if two elements are majority elements in the same array? Guys, that is a very, very interesting thing that Satyam has asked. Can there be two majority elements inside a single array? Satyam, think about it. Can there be two elements which are occurring more than n by 2 times? No, right? How 4 is greater? 4 is not greater than this, but the count of 4 is 5, right? We have to count the number of times this element is occurring. Don't have to return the element which is greater than n by 2. We have to count the number which is occurring more than n by 2 times. Okay. Cool. So what is going to be the brute force solution here? Brute force solution is going to be simply you run two loops for each and every element. You just check whether that element is a majority element or not. Select this element. In the remaining array, count the number of occurrences. If the total number of occurrences is greater than n by 2, return it. Otherwise, go to the next element. Check for this element in the remaining array. If it is occurring more than n by 2 times, return. What is going to be this time complexity of this approach? It's going to be order n square. Why? Because you are running two loops of size n. Correct? Okay, so brute force is not going to work. This is too slow. How can we optimize it? Using hash map, right? So some of you are saying that we can use hash maps. If you use a hash map, first of all, how can we solve this problem using a hash map? So this is a very, very good suggestion that use a. What is hash map? Is everyone clear with that? If you are not clear, you can skip this. If you are clear, you can think in this direction. Hash map is nothing but a key value pair, right? So you can have a key and you can have a value in the hash map. Now every array element becomes the key and the frequency becomes the value. So against 3, you keep 1. Then you again go to 3. You see that 3 has already occurred in the hash map. You increase the frequency. Okay. Then you go to 4. 4 is not occurred yet. You keep it and you put 1 here. So after you have iterated all the array, yes, it's totally like the dictionary in Python. Okay. After you have iterated all the array, you will be having all the array elements along with their frequencies. Okay. So 4 will be 5 at the end because the frequency of 4 is going to be 5 and the frequency of 3 is going to be 2 and 2 is also going to be 2. This is the value, the array element, and this is the frequency. After you have made this complete map, you can iterate over all the keys and you can figure out which of them is the majority element. This is one of the approach. What is going to be the time complexity of this approach? If you are not aware about what is a hash map, you can totally skip it. We will be covering hash map in details in the upcoming sessions. But if you are clear about hash map, then you can just think about what is the time complexity of this approach. This is going to be order n time complexity, correct? What is the space complexity here? You are using a hash map which is going to cost you order n space, right? Order n time complexity plus order n space complexity. Okay. You have to solve this problem in a linear time with constant space. Okay, this has to be your time complexity, this has to be your space complexity. Is the requirement clear to everyone? You cannot use a hash map. If you are not clear about the hash map approach, completely skip it, because this is something that you cannot use in the question. Okay, you have to solve this problem in order and time complexity, order one space complexity. Okay, think about it. This is going to be something which we'll discuss in the next class. Right, so in today's class we'll first discuss the majority element question that we discussed in the last class, and then we'll solve one more problem which will be based on a two-dimensional array. Okay, so the problem that we left unsolved in the last class was that you are given an array and you have to find the majority element of that array. The problem says that you are given an array, and in this array you have to find the majority element. Okay, the majority element is an element which is occurring more than n by 2 times, more than n by 2, where n is the size of the array. Okay, so if the array size is 9, the element has to be there at least 5 times. Okay, it is possible that there is no majority element in the array, because there might be a possibility that there is no element which is occurring more than n by 2 times, right? Correct. So the brute force way to solve this problem as proposed by Sai is that you run 2 loops, and for every element you check the number of count of that element in the array. Right. So you will start from the first element, you will select this element, then you will check in the remaining part what is the total occurrences of this element. Okay. You can then see if the total occurrences is greater than n by 2, you can return it. Then you will check for the next element, then you will check for the next element, and so on. Right. So you will have 2 loops. One will be selecting a prospect candidate, the other will be checking if that element is a majority element or not. This approach is going to cost you order n square time. Okay. We discussed a more optimized approach also, which was involving a hash map. If you use a hash map, what will be the time complexity? If you use a hash map, since in hash map you can store a key value pair, right? So a hash map is nothing but a key value pair. If you are using Python, you can think in terms of a dictionary. Right? So key can be your array element, and the value can be the frequency of that array element. So you iterate over the array once, and you keep the count of frequency of all the elements in this hash map. Once everything is done, or while calculating the frequency only, you can just check if there is an element which occurs more than n by 2 times. If any element occurs more than n by 2 times, then you can return it. Okay. So this approach is going to cost you order n time, but order n space as well, because you will be using hash map. Okay. How to create hash map in C? You can use unordered map in C. Now the question here is that we have to solve this problem in order and time complexity without using any extra space. So we have to solve this problem in constant space complexity without using any extra space. Okay. Okay, so most of you are saying that now you will apply the Moore's voting algorithm, which is absolutely correct. Okay. Okay, we have one more approach. The other approach says that you first sort the array. If you sort the array, since the majority element is going to occur more than n by 2 times, right? And once you sort the array, all the similar elements will be arranged together, right? So some similar elements will be there. Then if there is a majority element, then it will also be there, and then some different elements of similar type will be arranged together. If there is an element which is occurring more than n by 2 times, once you have sorted this whole array, either you can do a linear iteration, or maybe you can just check the middle element and check the count of that element as well, right? So if you sort the array, what will be the time complexity? If you are using the most efficient sorting algorithm, even after that, what is going to be the time complexity of sorting the array? It's going to be order n log n. Right? You can use quick sort, merge sort, or heap sort, right? and all these sorts are going to run in order and log n time complexity. If you are not sure about all these sorting algorithms, we will be covering them in the upcoming classes, so don't worry about it. If you already are familiar with the sorting algorithms, then you can sort this array, and then you can iterate over the array and count the occurrences of all the distinct elements, right? So in that case, the time complexity is n log n, which is absolutely greater than order n, right? So this is again not an optimal approach. Okay, so let's discuss the idea behind the most optimal approach for this problem. Okay, let's try to change the perspective. So first, let's consider an example. Let's take this example only. Okay, so if there is a majority element, the question says that the majority element will be occurring more than n by 2 times, right? The count of majority element is always going to be greater than half the size of the array. If there exists a majority element, can I say that the collective counts of all the other elements will always be less than n by 2? If majority element exists, if there is a majority element, can we say that the count of all other elements combined will be less than n by 2? Obviously yes, right? Because half of the array has been occupied by the majority element. If you collect all the majority elements together starting from the 0th index, and if this is the n by 2 mark, the majority element will definitely occupy, starting from 0, it will go more than n by 2, right? So the remaining space that is left in the array is obviously less than n by 2, correct? Okay, now if this is the case, if everyone is convinced that the count of all the other elements combined is going to be less than n by 2, now let's try to see this whole scenario in terms of, let's say, election results. Okay, let's actually consider all these array elements as the results of an election, result of different constituencies. Okay, so these are different parties. This is a party 4, this is a party 3. Okay, and let's try to see in terms of the election results. Okay, so the party to which the majority element belongs, okay, in this case is going to have 1, 2, 3, 4, 5. 5 constituencies have been won by the majority element, right? And if we collect all the other elements together, this is going to be 1, 2, 3, 4. Okay, so we have some other element A and some other element B, right? So these are the results from different constituencies. These 5 constituencies have been won by the majority element, and all these are won by different candidates. Okay, so if you remember the 2019 general elections, there was a party BJP which was in majority, and then there was something called as Mahagathbandhan, right? So in Mahagathbandhan, there were various parties which they combined hands and they were fighting against BJP all together, right? So you can just assume that these all are the constituencies won by the Mahagathbandhan, and these all are the constituencies won by BJP. Now, if the election commission says that 2 out of all these constituencies are being disqualified, there has been some cheating in 2 of these constituencies, so we are removing the results, we are not counting the results of these 2 constituencies. So if the election commission says that one of BJP's constituency and one of the Mahagathbandhan's constituencies will not be counted in the election result, if these 2 are removed, who is going to win the election? If 2 constituencies here are removed, who is the new winner? Initial winner was BJP, right? Now who is the new winner? You can quickly count the total votes and quickly see who is winning it again, right? It's still BJP, right? So what we have done, if you look in terms of this array, you have removed one occurrence of the majority element, and with that you have also removed one occurrence of a non-majority element, right? So we have reduced the size of the array by 2, and the occurrences of the majority element has been reduced by 1. Okay, let's say 2 more constituencies were removed. So one from BJP and one from Mahagathbandhan again were removed. Who is the winner? Who is the new winner now? It's again BJP, right? You can quickly see that it is still in majority. It is still having a size more than n by 2, right? So what we have done here is we have removed one occurrence of the majority element. With that, we have also removed one occurrence of a non-majority element. Okay. Again, if you do the same thing, you can see that BJP still remains in power. If you remove 2 more constituencies, we have only one constituency left, which is of BJP. So the idea is that if with every occurrence of the non-majority element, if you remove one occurrence of the majority element, at the end you will be left with at least one occurrence of a majority element. So the idea here is that if I am removing one occurrence of any non-majority element with one occurrence of a majority element, the majority element still remains the same. Let's try to see it from other analogy as well. Okay, one another analogy could be that there are 2 countries, or let's say there are 3-4 countries, and 3 countries are fighting against one country combined. So there is a country C1, there are country C2 plus C3, and let's say C4. Okay, now C1 has got majority of soldiers, right? So the soldiers that C1 has, let's denote them as S. So let's say it has got 7 soldiers. Okay, and all these other countries combined, okay, or let's say that let's represent all these soldiers by I. Okay, then we have some more countries, and we have 3 soldiers in the country C, or let's say 4 soldiers in a country C. We have 2 soldiers in a country P, and we have 1 soldier in a country B. Okay, now since initially the number of soldiers in the country C1 have outnumbered all the soldiers in all the other countries combined. Now if one soldier here dies with one soldier of any of these countries, who is going to have majority of the soldiers? Will that change? So initially C1 is in majority, right? Now very similar to what we saw in the election, if this soldier dies with this, if these two kill each other, still C1 has got more number of soldiers, right? Actually here we have one less soldier. Now it is in majority. So initially it is in majority, right? Now if one soldier of C1 kills or dies with one of the soldier of all these countries combined, still C1 is in majority. The idea is, if you are removing one occurrence of the majority element with one occurrence of any other element, the majority element still remains the majority element. Can we use this idea to solve this problem optimally? Let's now bring back our example again, and let's try to do a dry run on the example. So we have all these numbers. Now if I remove one occurrence of the majority element with one occurrence of any other element, let's see what remains the result. Okay, so if I'm removing 4 with 2, 4 is still the majority element of this remaining array, right? If I remove 3 with 4, again 4 is the majority element, right? If I remove 3 with 4, again 4 is the majority element, and finally we are only left with 4. Okay, cool. Now the question is that you don't know initially which one of these is the majority element, right? If you don't know which one out of these is the majority element, how are you going to cancel the occurrences of all the other elements with the majority element? The question is, do you need to know the majority element? If I slightly change the initial observation, so initial observation was that if we are removing one occurrence of a majority element with one occurrence of a non-majority element, the majority element remains the same. But if I change this observation to, if I remove 2 distinct elements at a time, If I remove two distinct elements at a time, the majority element remains the same. Will this also be correct? If instead of always selecting one of the majority element, if I'm selecting any of the two elements, making sure that the two elements are distinct, that is also going to cause the same effect, right? Because if you are not selecting one of the majority element, then this will definitely be in majority because you are not removing it, correct? So you don't need to know the majority element initially. Okay, what you need is what is the current element that you have. Okay, and what is the count of other elements. So if we are here, if you are trying to find the majority element in this array, you don't need to sort, you don't need to get the counts of all the elements. What you can do is you can just maintain a variable and you can maintain the count. So initially when you are at 3, you can say that 3 is your majority element, count is 1. When you get another occurrence of the same element, you can just increase the count. Now you get a different element. When you get a different element, you can say that since this element is not same as this majority element, you can remove these two occurrences from the array. So you are not counting it and you are changing this count to 1. So this means that you have removed one occurrence of 3 and you have removed one occurrence of 4. Then you go to 2, again you get an element which is not same as the current majority element. So you will cancel out both of them. So now you are removing this occurrence of 2, so you are not counting it and you are also reducing this count from here. Okay. Then you go to 4 and now you see that 4 is the new element and the current count of majority element is 0. That means if count is 0, there is no element that you have here, right? So now you can change your majority element to 4 and the count now becomes 1. Okay. Then you again go to 4 and you see that this is same as the initial element. So you will now increase the count from 1 to 2. You go to 2, you find that this is a different element, you can remove the counts. So if you remove the counts, you are not counting 2, plus you are decrementing the count of current majority element. Then again, you see that here you have 4. So you will increment the count. Again, you get 4, you increment the count. The final element that you are getting with non-zero occurrences can be your majority element. Okay. Great. If this is clear, will this always be the majority element? Will the final element which we are getting, is it always going to be the majority element? No, not necessary. This is not necessary that this element is always going to be the majority element, because there can be cases where there is no majority element in the array, right? This one. So in that case, whatever answer you finally get, you will have to actually count the occurrences of that in the initial array. So here if you get 4 with a count which is greater than 0, you will again you will run a loop over your initial array and you will count the occurrences of this prospect majority element. This can be the majority element, not sure. Okay, this is a prospect, this is the only candidate for a majority element. So if you get something here with a non-zero count, you will just check here and count the occurrences. If they are greater than n by 2, then you can say that this is the majority element. Okay, I will just repeat the counting part again. Okay, how we are counting. So is everyone clear with the idea of this algo? The idea is that whenever you get two distinct elements, you remove them. Okay, if you are getting two distinct elements, you remove the occurrences of those two distinct elements. So if I'm getting 3 and then let's say if I'm getting 4, I will try to remove both of them. Okay, so what we are doing here is we are maintaining a current majority element and we are maintaining a count. Okay, so if you get 3, you increase the count. So you have, let's consider a different example. Okay, let's take an example given by Vijay Sai, which is 3, 3, 3, 4, 4, 2. Okay, so we'll be maintaining a majority element and we'll also be maintaining a count. Okay, you get 3, you say that 3 is the current majority element. I don't know what is going to be after 3, but 3 will be the majority element. Count of 3 currently is 1. Then you go to 3 again. This is same as the initial or the current majority element. So you increment the count to 2. Okay. Then you go to 3 again. You will increment the count to 3. Then you go to 4 and now you get a different number. What was the algo? What was the initial observation that we made? The observation was if you remove 2 distinct elements, the majority element remains the same. So if I get 2 distinct elements, I will cut them down. So I will not count the occurrence of 4. So I'm ignoring 4 and simultaneously I'm also reducing the count here. Okay. Then I get 4 again. I am again reducing the count. Then I'm getting another different number. So I'm reducing the count. Count becomes 0. If count becomes 0, that means there is no majority element. If let's say there was another 3 and okay, so in this case basically you are not going to get a non-zero count, but it might be possible that you can get a non-zero count even when you don't have a majority element, right? So you can have something like 1, 2, 3, 4 and then let's say 5, 5. Okay, in this case if you run the same algo you will get a non-zero count at the end, but there is no majority element in this array. So after you get a non-zero count, you will have to check in this whole array. You will have to count the number of occurrences of your prospect candidate. Okay. Okay, Rahul is asking, will it work for n by 3 problem? Yes. Okay. So in this case, the question was that majority element should be occurring more than n by 2 times. Now there is a variation of the same question which was asked in Google, where the problem says that your majority element is an element that occurs more than n by 3 times. Okay, now using the same concept, you have to solve this problem. Okay. Yes, Ayush, this will work. Okay. If you want, you can also try to see it mathematically. Okay, you can just take an array of size n. Let's quickly see how if it is going to work mathematically or not, right? So the initial size of the array, size initial is equal to n, right? If you are removing 2 elements, then the size will be n minus 2. Now, if there is a majority element, then what should be the minimum count of that majority element in this initial array? That has to occur more than n by 2 times, right? These many times. If you have removed 2 elements, from this array, at least one of them can be the, or at most one of them can be the majority element, because you are removing 2 distinct elements, right? So the count of new majority element in this array is going to be n minus 2 by 2 plus 1, right? Is it making sense, guys? So the initial size of your array was n. After removing 2 elements, the size becomes n minus 2. Initial count of the majority element was greater than n by 2. So the minimum count would have been n by 2 plus 1. Now the count is size by 2 plus 1, right? And if you have removed 2 elements, only one of them can be the majority element, right? So what would be the new count of this element? The new count of this element is going to be the initial count minus 1. This is going to be n by 2. Okay. And if you solve this is also going to be n by 2. So you can see that this is the count of majority element which should be there in this array of size n by n minus 2. And this is the count of the initial majority element. So you can say that the initial element still remains the majority element. Now you can do the exact same exercise for n by 3 also, and you can check whether the same algo is going to work or not. Okay. What is the time complexity of this whole algo? So we are running a single loop, right? We are running a single loop and we are just maintaining the current majority element and the count. Okay. So the single loop is going to count you order n time complexity. What about the space? We are using only 2 variables, right? We are not using any array. We are not using any hash map. We are using only 2 variables. So the space is going to be constant. So will you be able to write the code for this? could you go through an example of n by 3? Example of n by 3 is there in the test that you have received yesterday, right? You can just go through that problem and examples are listed there. You just have to check using this exercise that will the same approach work or not. If you are able to do that, then you can solve that problem as well. Okay, let's solve the next problem. Now the next problem is also a very interesting problem. Yes, the algo that we have discussed, this is the Moore's voting algorithm. Okay, so let's discuss the next problem. In the next problem, you are given a matrix. Okay, this matrix is sorted row wise. All the rows of the matrix are sorted and all the columns are also sorted. Okay, what is a matrix? Matrix is nothing but a two-dimensional array. Okay, so all the rows are sorted in ascending order and all the columns are also sorted in ascending order. So here we have a matrix which is sorted all. So you can just quickly observe all the rows are sorted in ascending order and all the columns are also sorted in ascending order. Okay, you are given a target and you have to search the target in this matrix. Okay, so for example, if your target is 37, you have to identify whether the target is present in this matrix. If it is present, then what are the coordinates? Okay, so if the target is 37, 37 is present and it is present here, right? So you will be returning the coordinates of 37 in this matrix. Okay, is the problem clear? Okay, for those for whom the problem is not clear, I will quickly repeat it again. You are given a matrix where each row is sorted in ascending order and each column is also sorted in ascending order. Okay, then you are given a target and you have to find and return the coordinates of the target in this matrix. The dimensions of matrix is n cross n. Okay, what is the brute force here? Can everyone solve this problem using a brute force algorithm? We simply have to start from here. Okay, then traverse all the rows, each and every element, check if that is equal to the given target or not, right? If you do this, what is going to be the time complexity? If you are traversing each and every element, how many elements are there? This is going to be order n into n. Right? There will be one loop which will run from 0 to n, then there will be another loop inside that which will run from 0 to n, right? Okay, now some of you are saying that you can solve this problem using binary search. Now, for all those who don't know how binary search works, you can just skip this part. We will be covering binary search in details in the upcoming classes. For all those who know how binary search is going to work, can you guys quickly think of an approach which uses binary search? See, all the rows are sorted. Okay, if all the rows are sorted and you have to search an element in sorted rows, can you use the fact that the rows are sorted? Yes. So in each and every row, you can apply binary search, right? What is the time complexity of doing binary search on an array of size n? If you are running binary search on an array of size n, the time complexity is log n, right? And if you are doing binary search in all the rows, how many rows are there? So in this case, we have n rows and the size of each and every row is m, right? So in our case, if we apply binary search on every row, if you apply binary search on each and every row, what will be the time complexity? There are n rows and there are m columns. So there are m elements in each row, right? So this is going to be the time complexity. Okay, cool. Can we do better? Okay, if we want to do better, let us try to make some quick observations. Okay, if this is the matrix, let's draw a matrix here. Where can we find the smallest element of this matrix? Can you guys quickly tell me the coordinates of the smallest element present in this matrix? The smallest element of this matrix is going to be at 0, 0, right? This is the smallest because all the rows are sorted, all the columns are sorted. So this is the smallest of all. Where can I find the largest element of this matrix? The largest element of this matrix is correct. It's going to be at the cell n-1, comma n-1. This last cell, right? This is going to be the largest of all. Now, if the target element is smaller than 0, 0, or if the target element is larger than this element, can I directly say that that element is not going to lie inside this matrix? If your target is less than 0, 0, or your target is greater than the last element that you have, which is present at n-1, comma n-1, can we say that this target is not present in the matrix? Yes. What if this is inside the range? What if the target is inside the range? So if we are starting from this point, if the target is greater than 10 and it is less than or equal to 71, and I'm starting my search from this point, can the target be present in this row? If it is greater than 10, can the target be in the first row? Yes, because all the elements of this row are greater than 10, right? So target can be 30, it can be 40. Target can also be 17 or 15, right? So it can also be present in this column as well. So if the target is greater than 10, it can be present anywhere in the matrix, right? If we are starting the search from here, we are unable to make any conclusive decision, because all the elements here and all the elements here are following the exact same property, which is that they are greater than 10. So this is not allowing us to discard any of the search space, correct? Let us start the search from this block. Now, if the target is smaller than this, can I say that the target has equal chances of being present in this row, in this column, as well as in the last row? Because all the numbers in this column are smaller than 71, because the column is sorted in ascending order, right? All the elements of this row are also smaller than 71. So again, we don't have any decision that we can take, right? We cannot discard any part of the search space. All the values are still relevant. Okay, let's try to search from this point. Now, can you guys figure out a pattern? If I'm standing at this point, if I'm standing at 50, what can I say about all the elements present in the first row and all the elements present in the last column? If this row is sorted in ascending order, can I say that all the elements of this row are going to be less than 50? Similarly, all the elements of this column will definitely be greater than 50. Is it going to help us make any decision? So if the target is less than 50, can I say that target will never be present in the first column? If the target is less than 50, the column is sorted in an ascending order, right? If the target is less than 50, all the elements in this column are definitely going to be greater than 50. So the target will never be present in this column. Now I am able to make a decision to discard some part of the search space. The search space has become smaller, right? All these values are now irrelevant. Okay. So if the target is less than 50, I can directly move to this cell and I can start comparing from this cell. Now, if the target is greater than 40, can I say that that target will never be present in the remaining part of this row? If the target is greater than 40, I know that all these elements are less than 40 because the row is sorted in ascending order, right? So now these elements become irrelevant for us. So I can discard this complete row. Okay, and now I can start my search from this cell which has 45. Again, I can check whether the target is smaller than 45 or greater than 45. So at every step, I am able to make a decision of either discarding one row or discarding a column. So let's say that if the target that we have to find is 26. Okay, if 26 is the target that we have to find, at this step, I know that 26 is smaller than 45, and since this column is sorted in ascending order, all the elements below 45 are useless. right? 26 can never be present in this part because 26 is smaller than 45. So I will move my pointer to 35, right? Now, when I'm at 35, I know that again 26 is smaller than 35. So all the elements of this column also are useless for us. Okay. So we move to 25. If currently I'm standing at 25, I can see that 26 is bigger than 25. If 26 is bigger than 25, all the elements present here are useless for us, right? So we move down. Now when we move down, we figure out that this element is nothing but the target. So we have found the target. So in every step, we are either able to discard a complete row or we are able to discard a complete column. So you will be running a loop. You will be starting from the topmost corner, right? You will be starting your code. You will be starting your search from this top right corner. And you can say that if this element is equal to the target, then you can directly return true. Or if you are asked to return the coordinates, you can do that. Now, if this element at the top right corner here is smaller than the target, then what can we say? We can say that all these elements are if this element is smaller than the target, then these are useful, but these elements are useless because these all elements will also be smaller than the target, right? So what can we do in this case? We can just switch to the next row. So we will be doing I++, okay? Else if this is greater than the target, then what can we say? If this element is greater than the target, then all these elements will also be greater than the target. So we can switch the search space or we can switch the column to the previous column, right? So we can move to the previous column. So that will be J minus minus, okay? And there will be a while here. Can you guys tell me what should be the condition which should come here when we have to stop all these things, when we have to stop the search? If we find the target, then we are returning. So that will obviously break this while loop. But what should be the condition? What should be the boundary cases for this search? We're starting the initial I value from where we are starting is 0, right? This is the first row from where we are starting. The initial column value is the last column, which is m minus 1. So these are the initials from where we are starting. Now what should be the restriction, or what should be the boundary where we can go? This I. So now you can also pay attention to how we are changing these variables, right? So I is always getting incremented, j is always getting decremented. I is currently at the smallest possible value, which is 0. J is currently at the largest possible value, right? So if you are incrementing I, you have to make sure that you are not going out of this matrix from here, right? So I should always be less than n, okay? And if you are decrementing j, you have to make sure that j does not become less than 0, right? So j should always be greater than or equal to 0. So this is your boundary case till which you have to run this loop. And if you find the target, it's good, return true. If this current element is less than the target, all the elements of the first row will also be less than the target. So ignore them, move to the next row. If this element is greater than the target, then all the elements of this column will also be greater than the target. So ignore them, move to the previous column, okay? And we search the element. What is the time complexity? Some of you are saying log of m into n. Is it log? What is the time complexity? So to get to the time complexity, focus on what is the maximum number of steps that you are going to take, right? What is the maximum number of values that I and j can take? I is starting from 0, it can go till n. J is starting from m minus 1, it can go till m. So what is the total number of combinations of these values that can be there? In every in other terms, you can also think in this way, that in every step, either you are ignoring one row or you are ignoring one column. There are total n rows, there are total m columns. If in the worst case, if the target that you are finding is present here, you will be ignoring all the rows above this and you will be ignoring all the columns after this, right? So the time complexity is going to be n plus m. What if matrix is not sorted? If the matrix is not sorted, you cannot apply this logic, right? Why not maximum of n and m? That is because you can do both of the things, right? If you are moving from this corner to this corner, you will have to take all the n steps in order to move from here to here, and you will also have to take all the m steps in order to move from here to here. This is the worst case, that you go down as much as possible and you also go left as much as possible. Okay, so that is n plus m of every row. Okay, Vijay, you can just try to see some of the example. Just try to dry run your approach on this matrix itself. You will find that chances of finding your element in every row will be there. So if let's say I am talking about if I have to find 30, 30 is smaller than all these numbers, right? So 30 can be present in any of the rows. 30 is greater than the first number of all the elements in the first column. 30 is less than all the numbers in the last column. So 30 has got a chance of being present in each and every row. So you will have to apply binary search in every row. And if you are applying binary search on each and every row, then that will be n log m. Pseudocode, we have written the pseudocode, right? This is the pseudocode. Or this is the actual code, not the pseudocode. This is how you are going to initialize your I and j, I from 0, j from m minus 1. Okay. And I hope you have learned something in today's class. Please do solve the problems and please do subscribe to the channel so that you don't miss any new class update. Okay.